Okay, we are live on YouTube and I will start the recording on the cloud. Yeah, the recording also has started. So welcome everybody to the Silicon Valley chapter of IEEE Computer Society. This is the second annual conference on applied data science, ICADS 23. I'm the chapter chair, Vishnu Pendyala. Ours is the largest chapter in the Silicon Valley section of IEEE with over 3,500 subscribers in our mailing list and a strong following of over 12,300 on Twitter alone. We are uniquely positioned by virtue of our location and available expertise, and thanks to the online experience that the pandemic brought forward, we are now able to avail of expertise from all over the world. Like today, we have some great speakers from India, Greece, and other places. And of course, from the Silicon Valley as well, both representing the industry and also the academia. So we'll start off the session with a few case studies by Professor Mohana Reddy from India. He's joining us from India. It's 8:30 p.m. in the evening for India. He'll be presenting a few case studies, very interesting case studies. The title of the session is Artificial Intelligence-Based Decision Frameworks for Smart Environments. The first case study is Online Examination Question Classification System. We all know the advancement in education has emphasized the need to develop an efficient online examination system. So here, the assessment of the exam questions carried out qualitatively and the cognitive levels of students are mapped to the Bloom's cognitive levels. So we all know, particularly those who are in the education domain, know Bloom's taxonomy. So apparently, we map the cognitive levels to these various levels in the Bloom's taxonomy. This helps evaluate the subject-related learning by students. For this task, a novel optimized framework referred to as QC-DcCapsGAN-AOSA is developed by combining the dual-channel Capsule Generative Adversarial Network with the AOSA, which stands for Atomic Orbital Search Algorithm, for pre-processing a real-time online examination questions dataset in Indian universities. So that's the first use case. We'll get more details from the speaker, Professor Reddy. The second use case, or the case study, is on online exam proctoring system, which have become increasingly important in the education sector due to the need for remote learning during the pandemic. But even after pandemic, we are still practicing online exams. For instance, all of my exams are online. However, ensuring the integrity of online exams is a major challenge. Traditional proctoring methods may not be suitable for remote learning scenarios. So to address this challenge, Professor Reddy's team proposed an online proctoring system that uses deep learning and federated learning techniques to detect fraudulent behaviors during online exams. So 4 transfer learning models are used for classifying images captured during the exam to identify cheating behaviors on the online exam dataset. The third use case is smart home kitchen appliance, specifically a smart refrigerator. A smart kitchen is a smart home, IoT and AI-enabled appliances and devices that assure comfort, convenience, safety, and protection to the users. Most smart appliances available in the market are not economical and are beyond the reach of a commoner. A smart fridge is one such appliance. So considering this, Professor Reddy's team proposed a cost-effective, ubiquitous, and intelligent refrigerator framework. The proposed framework uses night vision images to detect and predict fridge items and provides a natural language interaction feature with the fridge. The framework aims to convert any standard refrigerator into its smarter version with minimal hardware and software requirements. So a YOLO V5 version 5 model of and a custom data set of night vision images are used for object detection. The object detection model achieved very good results compared to other models. We'll get more details from Professor Reddy directly. And the fourth use case is smart home kitchen LPG leakage prediction and alert system. LPG, we all know, is the most commonly used fuel for cooking at homes and households. Leakage of LPG can occur due to faulty pipeline connections, broken regulators, damaged cylinders, or any such reasons. LPG leakages can be disastrous. We all know that. So such leakages, when detected and predicted on time, can significantly help prevent any hazards. So Professor Reddy's team proposed to develop a gas leakage detection system using reliable techniques to avoid such situations. So they employ IoT sensor-based approach to find gas leaks in enclosed spaces. Deep learning methods like LSTM networks are used for tasks involving detection and prediction. So those are the case studies which will be presented by Professor Rammohan Reddy Guddeti. He received BTech in Electronics and Communication Engineering from Sri Venkateswara University in Tirupati, India in April 1987. He received his MTech from IIT Kharagpur and PhD in Artificial Intelligence from the University of Edinburgh, United Kingdom in 2005. He is currently working as a senior professor, higher academic grade of information technology at the National Institute of Technology, Karnataka, Surathkal, Mangalore in India. He held several administrative positions during his tenure at NITK, namely Head of Information Technology Department and Chairman of Central Computer and Data Center. Professor Reddy has more than 35 years of experience in teaching, research, administration, consultancy, and knowledge skills development. He has more than 250 research publications in reputed international journals, book chapters, and conference proceedings. He supervised 12 PhD scholars and one postdoc fellow. Currently, 4 PhD scholars are carrying out their research under his guidance. He guided several like 40 MTech project theses and 150 BTech projects. His research, of course, includes artificial intelligence, cloud, edge, fog, and mist computing, smart agriculture, social network analysis. He is a senior member of ACM, a senior member of IEEE, distinguished visitor of the IEEE Computer Society. Currently, he is a life fellow of IETE and life member of Computer Society of India. As part of research interactions, Professor Reddy has visited several countries, including Australia, Belgium, Canada, China, France, Germany, Italy, Japan, Malaysia, and so on and so forth, and of course, USA and UK. Professor Reddy has visited world-reputed universities like Cambridge, Harvard, MIT, National University of Singapore, and so on and so forth in various countries. He received the prestigious Commonwealth Scholarship and Fellowship funded by the Ministry of Foreign and Commonwealth Affairs, Government of United Kingdom for pursuing doctoral research at the University of Edinburgh, UK during 2002 to 2005. Professor Reddy also received national merit and state merit scholarships for pursuing school and college education. We are really fortunate to have him today with us. And over to you, Professor Reddy. Please take it away.
Thank you, Professor Vishnu Pendyala, for the nice introduction as well as overview of different case studies, so that my job will be made simple. And at the same time, also thanks to you for giving me the opportunity to interact with distinguished audience as far as this conference is concerned. And I will try my level best to utilize the given time. It's very challenging for me to focus on 4 different case studies, starting from smart examination, question classification system, part of online examination, followed by online proctoring system, and the smart kitchen application scenarios. And these are the different case studies as already introduced by Professor Vishnu Pendyala. And definitely I will try my level best. And let us start with the first research case study, that is online examination question classification system. But if you look at the overall picture of online examination, we have to consider one aspect from the student's perspective, other aspect is from the proctor or the invigilator perspective, so that we can monitor and check the integrity of the learner or student while writing the examination. So let us start with the examination question classification system. So this is a part of the work carried out by my postdoc researcher, Dr. Reddy over a period of 1 year since April 2022. And this work is related to development of an hybrid framework for question classification by combining dual channel capsule generative adversarial network and atomic orbital search algorithm, so that we can classify the questions while meeting the different cognitive levels as per Bloom's taxonomy. So definitely we need to consider the background scenario so that we can evaluate the quality of questions while meeting the and checking the cognitive levels of the students while considering the Bloom's taxonomy of different cognitive levels. And you know very well that online examination systems generally maintain question banks. And whenever the registered students for that particular subject appears for the examination, these questions are randomly generated by the examination system. And many such systems use the rule-based approaches, where the examination questions are generally fed based on the predefined criteria, right? So now, in our case, we have considered the following research objectives so that we can develop a system that automatically generates and classifies the questions so that we can evaluate the students' cognitive capabilities by considering different Bloom's taxonomy levels, and adapt and apply the orbital search algorithm for maintaining an optimal balance between the proposed dual channel capsule generative adversarial network and the computational efficiency, so that it is cost efficient, also computational efficient. And finally, we can evaluate the performance of this hybrid framework, that is QC-DcCapsGAN-AOSA, with the state-of-art benchmarking methods. So this is the research framework or architecture of our hybrid framework, wherein we have actually 4 different modules, starting from data collection with reference to questions for a particular subject, followed by pre-processing, followed by extracting the features based on TF-IDF, and finally the classification. So definitely in a traditional universities, we are not only focusing on normal or simple questions. Of course, the examination is a subjective, that is descriptive in nature, so that we can give the design type of questions, and we can evaluate the performance of the students based on their analysis and analytical capabilities, looking at different cognitive levels. So definitely we need to consider the entire subject as one unit, and how we will collect the data related to that subject in terms of complete questions framework. Then we can apply the pre-processing so that we can normalize the data, then tokenize, then the parts of speech tagging and stemming, right? So these are already known to the learned audience, but how we will extract the features using TF-IDF, but that is also known to the learned audience, but how we will make use of this AML DL framework, that is deep learning framework, particularly using fully connected layer block or group of layers, and how we combine these fully connected layers with atomic orbital search algorithm for optimized performance, so that we can consider a set of group of these fully connected layers with one-dimensional multi-scale, one-dimensional capsule, so that we'll get one-dimensional output for each of these turn frequency as well as inverse document frequency. So here we have to consider set of specialized this particular category of questions as far as categorization is concerned or classification is concerned, whether it is real or fake specialized category or left module specific, so that we can combine both corresponding to TF as well as IDF using this classification framework. Then finally, we can arrive at n different types of classes based on Bloom's taxonomy cognitive levels. That is a brief idea. The same thing is explained in the form of a flow chart, so that we can easily understand. So definitely, if you look at this on the right hand side, we have the basic modules in terms of their jobs, which are self-explanatory, and we can easily understand. But how we have developed this mathematical model using this TF-IDF in terms of these mathematical equations. And if we look at these equations 1, 2, 3, 4, and definitely we can easily understand that we have used the TF-IDF for extracting the features, right? So for each question, right? So that means set of questions. Then our aim is to classify the questions, and this classification of these examination questions is now dependent upon the Bloom's taxonomy cognitive level, like lower and upper cognitive levels. Then how we will give the priority? When this priority is maximum, when the priority is minimum. So that depends upon the verb or keywords. So keywords are now considered in terms of verb, noun or adjective or otherwise. So maximum priority is given to the verb, whereas noun and the adjective are considered as second rank, and other parts of speech are considered with the lower rates. So that is given by equation number 4. And the extracted question features based on a part of speech using turn frequency given by equation 5. And the difference between TF question and inverse document frequency question gives the part of speech question, right, multiplied by IDF. So based on equation number 6. But our aim is to see that these extracted feature vectors should be normalized so that we can reduce the complexity and that ensure that the classification if accuracy can be improved with less computational cost. So obviously we have to apply the normalization for these feature vectors as given by equation number 7. And in this equations 8, 9, 10, then definitely we have to apply this dual channel CAPS-GAN for classification of questions as per Bloom's taxonomy levels. So definitely we have to consider the two training mechanism for this GAN in terms of generator and discriminator. And we know very well that generator takes the data discrimination, and created question data generally recognized by the discriminator for generating new samples. So definitely, if you look at these equations 8, 9, 10, we have come across two generators, GAN-AB and GAN-BA, and two discriminators, dis-A and dis-B. And we have to consider the objective function, that is max minimum complex, so that we can optimize the performance as far as this classification framework is concerned. So as we know that we need to classify the question level as per Bloom's taxonomy, we need to consider this giant loss function that should be minimized with the help of this objective function. So definitely we need to consider the CAPS network, as we have already considered in the research architecture framework, where we have used convolution neural networks. And the main idea is to get the neuron output, obviously, with the maximum performance, so that we can get the desirable output vector. So the idea is how this data transmission is taken care by different capsules in the continuous layers. If you look at the architecture, definitely we will look at the fully connected layers and one-dimensional multi-scale, one-dimensional this output layer, etc. And we have to consider the classification tasks. So definitely that depends upon the number of classes, so related to cognitive levels. So let us consider K number of classes. And the final layer of CAPSNet also has K capsules. And all these are representing one level of the questions to be classified. So that means at a time, one question is now classified to a particular level of cognitive level as per Bloom's taxonomy. So the length of the capsule vector output shows the visual entity existence probability. So what is the probability of this particular classified output meeting this particular cognitive level class? So for optimizing the overall performance of this DcCapsGAN framework, we have to apply orbital search algorithm. So definitely we have to consider the fitness function, so that we can maximize the accuracy, classification accuracy with minimum error rate. So that means the difference between the desired and the actual output must be kept at lower level. That should be the error rate. So that should be as minimum as possible. So definitely for this optimization, optimizing the that means maximizing the accuracy while minimizing the error rate, we have to apply orbital search algorithm, atomic orbital search algorithm. So obviously the bottom line is how this orbital search algorithm is applied for tuning these weight parameters of this dual channel CAPS-GAN network. So here the basic idea is how we can simulate the behavior of these electrons in atomic orbitals, so that this AOSA algorithm is efficiently explores. That means computationally efficient, means with less computational cost, so that the search space is reduced. That means search space is now reduced, means fast searching, and thereby converging to the optimal solution with maximum classification accuracy. So coming to the results analysis, we have considered this simulation setup with the following details, with the following processor operating system details and programming language Python, metrics, accuracy, precision, recall, sensitivity, and reference score. And we have considered the two state-of-art methods for comparing the proposed hybrid framework in terms of these performance metrics, particularly using these state-of-art methods, QC, LSTM, CNN, and QC by GRU, CNN, right? So definitely we have considered our Karnataka University, this was a technological university computer science question papers during six semester span. That is from 2014 to 17 academic years. And we have considered the total 600 number of questions in English language, while considering 6 different difficulty levels. So from this data, we have considered 80% questions for training process and remaining 20% for testing process. And the performance of the proposed hybrid framework by combining the DcCapsGAN with AOSA for question classification is shown in this slide in terms of F1 score, precision, specificity, sensitivity, and accuracy. And if you look at these results, table results, particularly, these are the results of hybrid framework, right? The next slide will definitely give the comparative performance of hybrid framework, right? So error rate is almost less than 5% with good accuracy, more than 95, 96%. Average is around 97%. Similar, so this slide definitely, as I said earlier, that this slide will give the performance of our proposed framework, hybrid framework, with this two state-of-art methods. So there is a almost nearly 9 to 10% performance improvement in terms of these different classes corresponding to Bloom's taxonomy level, synthesis, that is nothing but the highest level, creativity, analysis, evaluation, knowledge, comprehension, application, right? So definitely we consider 6 levels of these cognitive levels. So the same results are reflected in this bar chart, right? Definitely there is a improvement of performance improvement in case of our proposed hybrid framework. And error rate analysis also is shown in these diagrams, in the upper diagram, as compared with 2 state-of-art methods. These are also hybrid frameworks. And the bottom graph shows the computational time analysis, particularly related to the computational time. So time, okay, so, and this is the overall performance of all proposed, the proposed algorithm in comparison with the 2 state-of-art methods in terms of these performance metrics for 6 different classes of the examination questions. So that is the overall performance. So these highlighted bold highlighted results are for proposed hybrid framework. So definitely, if you look at this one, definitely there is improvement. Sometimes it is 16%, sometimes it is more than 44%, depending upon the class, right? So 25% to 40% like that. So the summary for first research case studies is as follows. We have developed a hybrid framework with good accurate performance improvement for categorizing these online examination questions in mapping with the Bloom's taxonomy cognitive levels. And that is the effectiveness of proposed hybrid framework. And obviously, we have also focused in case of English, the questions are in English language. And if you consider other languages in Indian context, then definitely it is under the challenging task. So right now we have only focused on these professional courses which are generally taught, and evaluation is done in English medium. So obviously we have considered the English language. type of questions. And finally, the experimental results for first research case study demonstrate that the hybrid framework outperforms these baseline methods or existing methods in terms of these performance evaluation metrics. So that's about the first research case study. Now let us move on to the second case study that is also part of online examination, but now this is from the invigilator or proctor perspective. So on one side, students are writing the examination, other side, administrator, education administrator is now the teacher, has to monitor the integrity and code of conduct and ethics while students are writing the examination. How a proctoring system is generally checking these issues. Let us consider. Right. So definitely, we need to consider the activities of the students when they are writing the examination. That means in terms of normal and abnormal behavior. Abnormal means it's like a cheating behavior. Normal means they are fully engaged while writing the examination without any cheating behavior. But our aim is how this proctoring activity is secure as well as efficient. That is our focus. Let us now consider the objectives of this second research case study. So definitely we have to apply this computer vision as well as deep learning framework. But here, if you consider deep learning, the question is whether it is centralized deep learning or decentralized deep learning. So if you consider decentralized, then definitely we have to consider some sort of federated learning approach so that we can maintain the data privacy and the security aspects. So the first object is how to design and develop enforced estimation using this framework so that we can detect normal, abnormal head poses from the videos of these online examinations. Right. So then obviously we have to move on to the detection of the objects used by the students while writing the examination, like mobile phones, etc., using YOLO version model. And also when students are diverting their attention by moving their head or eye gaze movement, looking at the phone or internet with reference to abnormal behavior. Normal, okay, there is no problem. Abnormal behavior, definitely we have to detect these activities. And finally, for optimum performance, how we will take care of this hyperparameter tuning for optimizing the performance of this federated learning framework using grid search, genetic algorithm, particle swarm optimization. So because of time constraints, I will not focus into more details, but I will summarize what we have generally focused for this detecting the abnormal activities. So as part of human activity recognition, here human is a student, right? So definitely we need to consider the action recognition or activity recognition based on eye gaze tracking, head pose, body posture, real-time face recognition. Object is obviously is a smartphone or mobile phone detection. And now the decision is a classification, whether activity is normal or abnormal. If it is abnormal, yes, we need to identify. Is it exceeding the threshold limit of this abnormal activity, which is standard abnormal activity or cheating activity? So that activity can be sent to the proctor. That image can be sent to the proctor, right? So that is the general idea. So these are these are the different aspects related to head pose estimation, eye gaze tracking, right? Then obviously we have to look at both left and right gazes, right? And obviously we have to make use of YOLO version 3 model for computational cost effectiveness, so that we can detect the mobile or the smartphone or any book if the students are referring this book as part of this cheating activity. Of course, if it is open book, there is no problem because the students are permitted to open the books, either online books or offline books. That is different issue, right? So the thing, similarly, in other abnormal activity, in a particular scenario, a particular student can take help of other students also. Then question will come whether multiple students are appearing in a single screen, that is multiple faces in a single image, or single person or single face in single image. Single person, single image means it is normal activity. So obviously we have to detect such cases. So this is the overall action recognition framework using federated learning. So federated learning, you know very well that it is a decentralized machine learning model, right? So that is so definitely at the decentral level we can use a part of this backbone framework using these CNN models, right? Like VGG 16, ResNet 18, etc. But the idea is how we can make use of federated learning so that we can maintain the data privacy, so that we can conserve and preserve the data as part of this secured network. Because the identified person's image should not be shared with everybody. That should be only shared with the proctor, because it is a confidential information for further action. So as I said earlier, that we need to consider federated learning model, which consists of different clients, so that the data can be trained, and this trained parameters are to be sent to the server, not entire data. Please note this one, only trained parameter. Whatever desirable information after training we are getting, that trained parameters are only sent to the server. So definitely it is not entire data is sent. So that means the processing is done by local server, and the key parameters may be sent to the centralized. The data set is partitioned into K parts, where K is number of clients and NK is the number of images at each client, right? So the model is trained on each client will be on that NK number of images. Okay, now as I said earlier that we have considered 4 different backbone CNN models like BGG 16, ResNet 18, MobileNet, V2, DenseNet 121, etc. So we consider local model. So that means local server, right? And this global server or centralized server. So obviously we have to consider different steps. So here step 1 is server sharing the initial model, okay? And what are the weights of this, and related to the local parameter. So local data set, a chunk of data set is now considered as a training data for local server based on federated learning, right? So definitely we have to consider some n number of local servers based on based on federated learning. So in the step 2, we have to update these local models using private data and generating new updates like WI, that is W1, W2 up to W. And these parameters, trained parameters, are sent to the server. Okay, so now once you find out the key parameters, then with the help of these key parameters, we can produce the best model performance, and in the direction of tuning these hyperparameters of the federated learning. So it's a part of optimization process, and this will reduce the search space, or that will reduce the number of key parameters as part of parameter tuning. So for hyperparameter tuning, we have considered grid search algorithm, genetic algorithm, particle swarm optimization independently. Now we have to see which technique will give better performance, right? So these details are already many fundamentals of these grid search, genetic algorithm, particle swarm optimization are known to the learner audience. So I need not once again go into the details of these fundamentals. So coming to the experimental setup, we have used this hardware and we have used this software, and we have considered the data set, particularly online examination proctoring data set obtained from Michigan University website, where we have 300 images of 3 different classes like normal, abnormal. Abnormal means more than one person using mobile phone, significant action to detect normal and malicious or abnormal behavior of the students or cheating behavior. But the question is whether 300 images are sufficient. So if these 300 images are, if you consider, then definitely this data set is small, then definitely we have to face the overfitting problem. So hence we need to apply data augmentation techniques like rotation, clipping, Gaussian blur, color jittering, etc. to address this overfitting problem, so that we can get some sufficient number of data samples for training. And this is increased to around 1500 images or even more. That is, original size is say 300. Now after data augmentation, it is around 1500 to 1600. So more than 5 times. And for headboss estimation, we have used OpenCV, and using MediaPipe library of Python, the results are generated. And obviously we have to consider different head pose, like looking forward, looking right, looking left. It's like a head pose tilt with occluded also, right? Without occluding, with occluding. So now if you consider this one, say for example, head pose is okay, but mobile phone is detected. It is a false case. But say false case means it is not. So the detected action is abnormal, but actually it is not abnormal. It is a false case. But here you see the mobile phone is now is used by the the student. So then it is a true case. It is not false case. So it is abnormal case. This is actually is a false detected case. This is a true detected case. So if the candidate is caught during the examination involving such cheating behavior, then the cheating activity has to be shared with the proctor. So that definitely, now question is it a minor activity or a major activity? So for that we have to measure, we have to monitor. If it is very, very trivial case, or then we have to observe for more than one time. If it is repeatedly observed, then immediately then we have to send that image corresponding to abnormal activity to the proctor. So the experimental setup for federated learning, details are given in this slide. We have considered 5 epochs for each round, for each client. And as I said, that we have considered 4 backbone architecture models for decentralized federated learning model, which is trained for 50 rounds, right, for centralized model. Okay. Then number of clients, 3, batch size 32, and training learning rate is 0.001. That is 1 into 10 power minus 3. And input size is 224 by 224 pixel squares. Optimizer is stochastic gradient descent. And as I said earlier, that we have considered 80% to 20% training and testing ratio. And these are the results corresponding to 4 different models. In terms of accuracy, precision, recall, F1 scope. And please note that these are the results for different centralized deep learning models. Right? But we have to move on to decentralized federated learning model. So we have to perform the experiment. For the different, okay, these are the other results of centralized deep learning models, 4 different deep learning models in terms of accuracy, loss, function graphs, right? Okay, so then these are the results of decentralized federated learning. So now definitely you can look at the results of centralized and decentralized. So these are the, okay. So if you look at this slide, this is IID data. This is independent and identical data, identically distributed data, right? So we have to consider this type of IID, non-IID data as far as decentralized federated learning. Whereas in centralized, we have not considered such IID or non-IID data. So these are the results of decentralized federated learning on IID data. And this slide will give the results of decentralized federated learning on non-IID data. Now, results of custom workload for different workload, like 25%, 35%, 40%, when we customize different workload distributions. See here in the first table, topmost table, 25%, 35%, 40% workload results. And in the middle row table, we have 10%, 20%, 70% workload. And bottom row table, 10%, 10%, 80%. Because we consider 3 clients. So definitely when we consider 3 clients with the different workloads, right? So 3 clients, we consider 3 clients, total workload is of course 100%, but the client 1 with 10% load, client 2, 20%, client 3, 70%, as far as the middle table is concerned. In the first case, 25%, 35%, 40%, bottom 10%, 10%, 80%. So accordingly, results are tabulated for different workload distributions. As I said earlier, that we have considered different algorithms for tuning these hyperparameters of this federated learning, using grid search algorithm, using the genetic algorithm, using particle swarm optimization. See, among all these different algorithms, using one model, ResNet one IID model, IID data model, then grid search gives highest accuracy, 99.75, with the best hyperparameters, 0.1532 among these 3 clients, with these learning rates values, local epochs, and batch size. Whereas genetic algorithm with 99.49 and particle swarm optimization with 97.47. But of course, we need to consider other parameters for further experimentation. Those results are in progress. And summary is as follows, as far as the online proctoring system is concerned. Particularly, we have used decentralized federated learning with and without hyperparameter tuning, right? So definitely, we need to carry out this facial recognition. We need to carry out head pose estimation. We need to carry out this abnormal activity recognition, right? Definitely, these results are encouraging. So some more experiments are being conducted. So definitely, results will be communicated to journal shortly. Now coming to the third case study, I think I have another 10 minutes, 15 minutes time. So I will brush up these 2 case studies with important features. So the third research case study is related to smart kitchen appliance. There are 2 such sub-case studies. One is a smart refrigerator, followed by gas leakage detection, but that is home environment. But if you consider industry 4.0 environment, we have to consider a bigger environment where we have considered not only LPG gas, including industry gases like methane, ethylene, carbon monoxide, etc. right? So such things also we can consider in case of different smart environment or smart factory environment. Okay, let us start with this third research case study. That is done by one of my research scholar, Ms. Sona Mundodi. She has developed a framework based on artificial intelligence IoT towards cost-effective and ubiquitous refrigerator with natural language interaction. So the details are generally will be discussed in brief. So definitely we have to focus on low cost, that means cost-effective smart refrigerator, so that we can detect and identify the items which are kept in the fridge, so that we will minimize the food wastage. Right, that is the main focus. The objectives are as follows, which are given in this slide. So as I said earlier, that we need to design cost-effective smart refrigerator model for detecting the items which are kept in the fridge using infrared cameras based on the fridge contents. And we can also implement user-friendly feature with the help of a mobile app as part of ubiquitous computing application. And how we will make use of enable interaction with the fridge using voice commands and obtain audio response. And how we will create or generate a custom data set using night vision images of these items which are kept are placed in the refrigerator randomly. When the fridge is closed, door is closed, definitely we have to make use of only night vision camera. Then finally we can analyze the items in the captured image by using transfer learning model for object detection based on this customized data set generated, customized data set. So this is the overall architecture of our proposed cost-effective smart refrigerator system. And this smart refrigerator system consists of 4 modules, namely camera module, that so that we can capture the images of the items kept in the fridge, and the captured image can be stored locally in the storage space. And if it is whenever it is required, we can upload this image to the file-based storage, right? Then second model is object detection. Definitely we have used the YOLO version 5 model for training, so that we can detect these fridge items from the captured images, right? Then model is available in local storage and mobile app. So as I said earlier, that we have used this local storage with the help of this TF flight model, and we can label these images, captured images, corresponding to different stored items of the fridge. And we have used Raspberry Pi night vision camera as part of this Raspberry Pi microcontroller. And coming to the third model, that is speaker model, we have to go for this NLP based user commands, so that we can convert speech to text and send the response to the client or user in terms of audio output. So that means play audio file using the speaker. And the final module is mobile application module as part of user interaction, right? The user interface and the user interaction. And obviously we can even go for user experience design also, UI and UXD part for effective and effective user interface and interaction design. So these are the screenshots of some of the captured images corresponding to the smart refrigerator. And this research scholar, Ms. Sona, has used her personal smart refrigerator of her home. And she has developed this AI and IoT based framework. And she has used night vision camera, right? So in this case, vessel is okay, that is utensil or container vessel with 0.14, and dry fruits is 0.80. Okay, and in this case, this is another case, captured detection vessel. See, this is another container. And these are the detection results with different values. See, vessel 0.46, chilies, and coconut like this. Okay, now, so that is what I mean to say, that what is the confidence score with which a particular item is recognized or detected. And in this mobile application module, we have to consider the user interface part, particularly for registration phase, as part of this Prism app is concerned. Then the options which are displayed on the mobile app screen, mobile screen, in terms of speak to the this module and check fridge status. So it is like is an interaction between the human and the machine. Machine is part of this refrigerator, and the human is the user, right? So definitely you have to carry out this activity related to detecting these items, stored items. So the setup for carrying out the experiment is shown in this slide. And as I said earlier, that she has used her personal refrigerator with this company make, with the Raspberry Pi 3 model keyboard, with night vision camera, with the 5MP infrared, with infrared LEDs, and the Infinity Bluetooth speaker, and the power bank, right? Software is a Google Colab notebook, Google Firebase, Android Studio chip. So the customized data set, of course, has created the data set over a period of time by capturing different images for different items which are stored in the fridge and labeled accordingly, like ice cream or dry fruits, whatever it may be, as far as captured images are concerned. And finally, these captured images are labeled. So finally, we have to apply this transfer learning for training this data set. If the data set is smaller, then we have to face the overfitting, as we have considered such overfitting case in earlier research case studies. But how we will avoid such overfitting problem? By using augmentation techniques, so that we can consider sufficient number of data samples. Suppose if the data set is larger one, then okay, no problem, we can directly apply. And we can make use of this YOLO version 5 model based on PyTorch for object detection using the transfer learning. And finally, we have to run this transfer learning model resource constrained devices. These are resource constrained. We have not sought the help of these cloud resources. We have only sought these fog devices, which are available in the form of this Raspberry Pi device with limited computational resource. So that's why these are resource constrained devices. And model is converted to a lightweight TF-Lite model using TensorFlow Lite, that is TF-Lite. And these are the screenshots of this night vision camera, the setup kept inside the refrigerator. And this is the internal layout of the refrigerator of Ms. Sona Mandodi. And these are the screenshots related to different test set images with reference to different parameters as shown in these tables, environmental parameters as well as model training parameters with the different learning rates, different image sizes, and the corresponding details are given, including batch size. And these are the results corresponding to different classes, right from batter vessel. Like batter vessel means like idli, dosa, batter, or vada batter, whatever it may be. Then vegetables like beans, brinjal, cabbage, carrot, chilies, coconut, container, like only vessels are containers, dry fruits, ice cream, lemons, tomatoes, vessels. Right, these are the number of images for each class and number of targets. And these are the values corresponding to precision recall, mean average precision at 0.5, mean average precision at 0.5 is to 0.95, right? So these are the results with reference to the training, with reference to box laws, objective laws, etc. And these are the results with, corresponding to precision recall curve and F1 score curve for all these considered or defined classes corresponding to items kept in the fridge. And we have compared the results of YOLO version 5 model with the different, like within YOLO version 5, we have different versions. YOLO version 5N, version 5S, version 5M, etc. Now, definitely, if you look at the weight, mean MAP at 0.5, MAP at 0.595, then definitely version 5N gives better results, right? Sometimes in majority cases, but if you consider 5M, MAP at 0.5 is 0.958, but slightly okay. This is okay. Version 5S is slightly 0.972. But we have to look at the memory, sorry, the weight in terms of the data storage weight or memory. Similarly, YOLO version 5N, which is showing better performance, and this model, results of this model, YOLO version 5 model, are compared with YOLO version 4 tiny and YOLO version 3 tiny. So definitely here also we got the better results, right? So this slide will give overall performance of different models of the YOLO version in terms of average precision of all classes corresponding to the stored items kept in the refrigerator. So in some cases 100% using YOLO version 3 tiny. In case of YOLO version 4 also tiny 100%. Right? So YOLO version 4 tiny use 100% from batter vessel to coconut. Right? Of course, in case of container 87.14 only, here 95.3. In case of dry fruits, it is 90 point, but in case of YOLO version 5N, we have 95%. So we have to see the performance in terms of average precision corresponding to all classes. Then we can arrive at which model gives the reasonably good performance. Right, reasonably good performance considering overall performance. So if you consider only YOLO version 3 tiny, then character recognition, dry fruits with less precision. Okay. Then coming to the cost estimation of refrigerator with this value added test bed components. Then definitely cost is roughly 224 US dollars, equivalent to 18,000 roughly in Indian currency. If you consider the cost of the refrigerator, cost of that is a single door refrigerator, cost of the Raspberry Pi, that is a fog device, embedded board, a night vision camera with LEDs, infrared LEDs, and Bluetooth speaker, and this power bank. Okay, this is the cost effectiveness. So the bottom line is we have developed a cost effective smart refrigerator module for detecting and identifying these stored fridge items using this ubiquitous system framework with good user interaction using a mobile app and NLP. And we found that YOLO version 5N model is lighter and faster than other object detection models. So it is suitable. It is suitable for low-end devices like embedded system, like microcontrollers and cell phones. And this can be easily trained on custom data set with MAP of at 0.5 of 97.5% and size of 3.8 MB. Cost is very less, 224 US dollars. That is roughly 18,000 rupees. If you add additional sensors and additional cameras, and at the most it can increase the price roughly to 400. So if you go for another night vision camera, if you have double door camera, a double door represent, definitely you need to have two. Then it is almost double, $400, which is less than the cost of intelligent refrigerator available in the commercial market. I think Professor Vishnu Pandyan, I
Yeah,
think 3 case studies are over, but my time is 1 hour is over. Shall I continue or shall I wind up?
we already have the next speaker waiting, so I think
I think better let me wind up.
yeah, that will
Let
be
me give some time for question answers.
yeah. So there is just one question on the YouTube live. There's of course some comments like interesting framework and a good interview, but one question, I think this is during the federated learning context, I think. So Rajiv Mathur is asking, by fold you mean a subset? I think you used the word fold somewhere.
Which one? That is related to online proctoring system for detecting the abnormal or cheating behavior. So
Yeah,
cheating is
yeah.
a smartphone is an object used by the student while writing the examination. If mobile phones are not permitted during the examination, most of the Indian universities, including the Indian Institute of Technologies and the NITs and universities, as part of standard examination practice, wherein students are not allowed to carry their smartphones, then electronic calculators, and other study materials, including books, unless it is open book examination. But even then, smartphones are not allowed. Then our aim is how to detect this object like smartphone. When the student is using smartphone with internet activity for browsing as part of copying, then we have to detect this object also as part of detection framework, as part of decentralized federated learning. Am I correct? What question is related to that one only? Federated learning?
Yeah, it was related to that. Yeah, I think that should answer the question. So I had a question myself. I was just curious. You use TF-IDF. Why not the transformer architecture for NLP related tasks like mapping to the Bloom's taxonomy?
Yes, yes. We have also thought of the NLP also, but because of time constraint of this postdoctoral research period for that student of 1 year postdoctoral period, we specifically focused on these deep learning techniques with initial framework. Then we can extend to NLP also. That is, but NLP, of course, he has also used NLP. Based on NLP only, we have to consider this word embedding, etc., for extracting the keywords.
Okay.
Please continue, Professor Vishnu. Your point is you can also consider NLP framework also, right?
Yeah, like BERT, the transformer-based architectures.
Yes, yes. Right now we have not considered like BERT and MBERT models, particularly multi-linguistic models, right? BERT models.
Yeah, yeah.
Yes, yes. We have not considered. Only we have considered only English-based questions. And because of the 1 year postdoctoral period, we have considered 2 models. One is the question classification, then answer classification. Answer classification means it is part of question classification only, but next evaluation of the answer speech of the students. That is the next module. Then the storing of this entire evaluation locally in the concerned organization by using blockchain technology. So because of this entire overall framework, we have not considered this NLP, particularly BERT and embed. But this is also in the pipeline. Thank you for your constructive suggestion.
Yeah, one other question I had was, I don't know how serious the privacy issues are in India, but in US, they are really very serious. We have this FERPA Act and things like that. So I was just curious, did you consider any leakage issues in federated learning? Like, could the data get leaked in the process of transferring the model or something?
No, right now we have not considered very big data sets. Even if you consider big data set, we have considered the chunk of data set because of training and testing and the infrastructure point of view. But definitely, this is very valid point related to leakage, data leakage, and but we are assuming that we are mainly focusing on key parameters for hyperparameter tuning, so that only the key and important parameters can be considered for training and testing, so that the computational cost is reduced. But if you consider the entire data set, yes, definitely there is a possibility of leakage. But we will look into these leakage aspects while considering these key parameters as part of hyperparameter tuning.
Okay, thank you, Dr. Reddy.
But we have not considered the security. Means if there is a leakage, then we have to go for some sort of other security framework also. Right now, we have not considered the security framework. Only we have considered the privacy using decentralized federated learning. We have not considered any security framework.
Okay, thanks for the clarification. Actually, I'm pretty sure there will be a lot of other questions as well. In fact, I myself have a few other questions, but I think we are in the interest of time. I will probably request you to conclude the session here. And if you permit me, I would like to share my screen just for a brief moment to present you with this certificate.
Yes.
So if it was an in-person session, we would have given you a plaque and stuff like that. But given that this is a virtual session, I wanted to present you with this certificate. Hope you are able to see the certificate.
I'm unable to see first.
1 second, then Zoom does this sometimes. Share screen.
Yes, this is now visible.
Yeah.
Yes. Thank you very much, Professor Vishnu Pendyala, for giving an opportunity to share my limited knowledge based on our research activities by our group members at NIT. Thank you.
Yeah, those were really interesting case studies. I wish we had more time. Unfortunately, we ran out of time, but we'll probably call you back.
Generally, 1.5 hours to 2 hours is fine. 1.5 hours is also fine. So that even then I have gone little bit faster to balance between important features and 3 case studies, if not 4 studies. So thank you very much. And any queries, I have shared my email ID. And thank you very much. So I'm leaving. And once again, thank you very much.
Yeah, thanks. So the next talk is by Professor Kostas. So Dr. Kostas, if you would like to share your screen, I'll stop sharing.
Yes, thank you, Vishnu.
Yes, I'll briefly introduce your talk and your profile, and then hand it over to you. So the talk is on performance-based content generation for language learning. We know the generation of appropriate content for serious educational games is an extremely important concept. since it can make all the difference between adoption and retainment of the game, which increase the possibility to achieve its learning objectives and attrition. So in the iRead project, Dr. Karpozis and team are creating a serious game and supporting applications for entry-level language learning. Content for the game is generated based on language models for each school year, learning models, and student performance with respect to each language feature. Several teaching and learning objectives are enforced through rules which govern content generation, such as fostering motivation and efficacy, promoting accuracy before automaticity, and allowing revision of already mastered language features. The main takeaway of the proposed this talk will be a flexible way to model language, teaching priorities, and student mastery, allowing for personalized learning and student analytics. The speaker today is another distinguished speaker as well, Dr. Kostas Karpozis. He is an assistant professor at the Department of Communication, Media and Culture, Pantheon University of Social and Political Sciences in Athens, Greece. In the past, Dr. Kostas served for almost 20 years as a research director at the Institute of Communication and Computer Systems, National Technical University of Athens since 1998, and participated in more than 20 research projects funded by Greek and European bodies. Most notably, the Humane Network of Excellence, within which he completed his postdoc in the field of mapping signals to signs of emotion, leading research efforts in emotion modeling and recognition. He served as an area leader for affective applications, the FP7 Tell Siren project as a technical manager. In fact, it was voted best learning game in Europe for 2013 by the Games and Learning Alliance Network of Excellence, and the H2020 iRead project, which produced Navigo, the winner of the Gala Serious Games competition for 2018. Dr. Kostas is currently serving as a member of the IEEE Explainable AI Working Group, which aims to produce standard for explainable AI, XAI, for achieving clarity and interoperability of AI systems design. Dr. Kostas is also the Student Activities and Computer Chapter Chair for IEEE Greece and a member of the National Bioethics and Technoethics Committee and Ethics Advisory Board for ICCS NTUA. Currently, the General Chair of the Foundations for Digital Games 2002 conference, the Chief Editor for Frontiers in Computer Science, Human Media Interaction section. He is a member of the editorial board for Springer's Journal on Multimodal User Interfaces, Personal and Ubiquitous Computing, and International Journal for Applied Intelligence. He is also on the editorial board of MDPS Big Data and Cognitive Computing and Virtual Worlds journals. In 2016, he co-edited a book on emotion in games, theory and practice, published by Springer. Besides this, Dr. Kostas is involved in a number of science communication activities, most notably FameLab Greece and OpenScience.gr. He's also an advocate for technology and computer science in primary schools, participating in the Girls Go Coding initiative and serving as an ambassador for the European Union Code Week in Greece. He participated as a speaker in 3 TEDx events, including the TEDx Athens in 2019, while in 2016, he authored a lesson on the TED platform titled, Can Machines Read Your Emotions? The lesson surpassed 300,000 views in its first week. We are really fortunate to have with us Dr. Kostas. Over to you, Dr. Kostas. Please take it away.
Thank you very much, Vishnu, for the invitation, first of all, and for the introduction. So the content of my presentation today has to do with my work in the IRID project, which you mentioned before, which produced, among other applications, a game called Navigo, a game suite called Navigo. And I'm going to briefly discuss the issues related to mobile language learning, some of the very important aspects which have not been tackled quite well from existing works. And then I'm going to proceed to discuss how we tackle them within the framework of the Navigo project, of the Navigo game actually, and the other applications that we developed. So in general, the main idea would be to create applications that facilitate language learning, and those applications should be able to be deployed in devices such as tablets or mobile phones. I really shouldn't have to discuss why this is important, given that all of our students now spend most of their time on their mobile devices, either studying or consuming content generated in social media. So it makes perfect sense to create content and applications that actually facilitate learning. Ideally, these applications should include the content that the students should go through. For example, read some passages, read some texts, and then perform exercises related or similar to the ones that a language teacher would assign them in class. So, for instance, these would have to do with closed-ended forms, such as completing multiple choice tests or filling the blank tests, or some forms of words or sentences or syntax and so on that students should respond with either true or false, and so on. That's on one hand. On the other hand, a very important part of language learning has to do with producing content. So writing essays should be a part of any successful and usable, actually, mobile language learning application. The problem with writing essays and marking them is that especially the marking part is very time consuming for teachers. And this doesn't only have to do with primary and secondary schools. It's a very important problem when it comes to university essays. Some of us may have classes up to 150 or 180 students. So marking essays by hand is very time consuming and very tiring. And of course, we cannot claim to be objective when marking all those essays by hand. In our application, we didn't go as far as including a tool to actually grade essays. But I think that given the recent advances in generative AI technologies such as ChatGPT or Bard or other models such as Llama and so on, one should be able to build a very reliable tool, at least to give an initial tentative marking of essays. So the content that I'm going to discuss has to do with reading exercises and then the closed form exercises that I mentioned earlier. So besides the actual testing and evaluation, which usually takes place with the exercises that I mentioned, we have to actually find and select proper content for each student. So for quite a long period of time, educational systems tried to create sort of a holy grail of educational content and applications. That is, select content that would be actually proper and fitting for all students in a given classroom. We now know that this is not possible. If you have a class of 20 or 25 students, it's not possible to find a single passage that is proper and suitable for all of them. Some of them may find it very easy, others may find it very hard, so they will be disappointed and skip class, or they won't read the passage at all. So selecting proper content for each learner is very important. And this has to do not only with the text that they would be given to go through, to study, but also with the content presented to them in the form of tests or exercises, the evaluation. Now, given that we have to adapt the content selection process to each student, we also have to take into account that there is a curriculum mandated content. So Our teachers have to select among a predefined selection of books or texts or passages. In the case of a Greek educational system, there is one single book that is given to all teachers. So the teachers should also be able to select that content besides the one that we select through the application. And this was actually one of the major issues with existing language learning applications, as I'm going to discuss in a few moments. So the major problem with existing language learning applications is that they're not very interesting. So what they're trying to do is try to actually create a gamified or visually more aesthetic version of the same content and the same evaluation mechanism that we use at school. So, for instance, in some lessons, in some courses, the teachers would write one sentence. They will leave one of the words out of the sentence and ask the students to select one of the 4 possible answers to complete that question. So this is the very familiar format that we all know and don't love, so to speak. So most of the applications, about 90% of the applications that you can find on the Google Play Store and the App Store, which are related to language learning, actually do this. They do just this. They have a more aesthetically pleasing and gamified version of the same evaluation mechanism. And as a result, students may try to, I don't know, spend 5 minutes or 10 minutes or even a week with each application, but after that period of time, they lose interest because it's the same boring tasks that they have to do for school. So it doesn't make sense for them to spend their limited time that they have available to spend it on the same tasks. They would go back to, I don't know, social media or games or something like that. Another important discussion that I would like to start is that of creating educational games. So if you go through the game literature, in most cases, the games are defined with respect to their narrative, with respect to the autonomy that they offer to each player. So within most games, players have the opportunity to use the game mechanics in different sequences and to perform different tasks in order to achieve the goals of the hero. So this is not the case with these applications. So there's only one way to go here to select the proper answer in order to get the points and proceed to the next question. There's no autonomy, there's no narrative, so there's no evolution of a game character and so on. So the concept of educational game really doesn't have to do with all these approaches. This is actually a screenshot from a Kahoot test. Kahoot is an online service where teachers can go to create their own automated tests and give them and hand them out to their class and so on. But as I said, the only form of evolution, the only form of digitization here has to do with the aesthetics and not the mechanics, which are the same to the ones that they use at school. Another important issue with existing language learning apps has to do with the concept of difficulty. So in most cases, students or users or players, however you want to call them, start with an introductory level. Some of the applications, such as Duolingo, which I'm going to discuss in a few moments, perform some sort of placement testing. So they have some initial questions which the student goes through or the player goes through. And then based on the answers that the player gives to those questions, they are actually placed on a more suitable level according to their performance. But at the end of the day, the concept of level is actually not fitted to a personalized understanding of learning. So, for instance, level 2 or level 3, which may be medium or hard when compared to level 1, mean that there are advanced questions or advanced concepts across all aspects of language. But language learning doesn't work like that. So someone may be proficient in one aspect of language, but they may lack knowledge on other aspects of language. They may find it difficult to work with double consonants, for instance. Double S is one of the very introductory, so to speak, language features which are taught in elementary schools. But others may have mastered those double consonants, but they may have difficulty working with suffixes and so on. And in addition to that, some of the applications may have some more, so to speak, fine-grained concepts of difficulty. But there is no chance that these progressions from level A to level B would be related to the curriculum. So in most educational systems, children of a specific class, level 1, level 2, and so on, are expected to have mastered specific concepts of language. And this progression is not mapped to the levels in language learning apps. Also, given the lack of personalization and fine graining that I talked about earlier. So Duolingo, most of the users of mobile devices must have tried Duolingo at some point, especially if you're not an English speaker and you want to try your luck with English or other languages. So Duolingo has been around for almost 10 years, so it's one of the, I would say, early attempts at language learning, and it's also one of the learning applications that has evolved over time. So Duolingo actually used the money that they collected from subscriptions to evolve their algorithm, and over the years it has gone quite well in terms of selecting and suggesting personalized content for the users. So one of the plus sides of Duolingo has to do with personalization in terms of selecting content, selecting the context of each language. For example, you may choose to learn English, and then within English, you may want to focus on technical words related to, I don't know, engineering, mechanical engineering or electrical engineering or so on. And someone else may want to delve into other aspects of terminology such as finance, or even briefly touch upon, I don't know, the usual phrases needed to travel to the United States and so on. And there's also the issue of variety of content. So Duolingo gives you the opportunity to experiment with pretty much every spoken language on the planet, including some fictional languages such as Klingon and Dothraki from two very popular TV shows. But also Duolingo has some of the same problems that I talked about earlier. It's disconnected from the curriculum that students should be taught at school. So it's actually more targeted towards adult learning. And this doesn't only have to do with the content and the exercises, but also has to do with the notification and the segmentation of language learning that it offers. So it's more fitting to someone who has to spend like 5 or 10 minutes per day instead of 45 or 90 minutes spent typically on schools. Another important issue that one has to discuss is that there's no real understanding of how content is selected. And this feeds back to the explainable artificial intelligence discussion. So we know that it works well, so the content is quite fitting, but it's actually not clear to us how the content is selected and which parts of a user's preference or performance is used to select that content. And this should be actually transparent, at least to the teachers. And they should be able to have some sort of profile information about each student and know where each student needs more work and they need more support. And this has to do with the fact that they are not using actually a model of the language. They're using the immense amounts of data that they receive from their users to train and adapt their system, and then use the emerging information from their users to select and produce the content for each exercise. Another issue that Duolingo does well, but it's actually a rare occurrence of a proper gamification, has to do with how to motivate and bring users back to the application. So a typical mobile phone user has, I don't know, 10 or 20 or 50 applications on their phones. Some of them we just download and install and use only once and never go back. So they're actually fighting for our attention. And one of the very few weapons, so to speak, that applications have to attract our attention has to do with notifications. Okay, so the idea would be that we want to notify users to come back to the application, but also once they are back in the application, we want to show them some concept of how the application should be used. So this is where gamification kicks in. In most cases, language learning applications award some points or badges for proper application use. And in order to foster some sort of competition between users, they also have leaderboards where you are placed in a position in the leaderboard given the points that you have amassed. And if you want to go higher up that leaderboard, you have to play more and succeed more and so on. This actually happens to most of the consumer applications that we use on our mobile phones. But a more meaningful gamification scheme would actually involve not just points, badges, and leaderboards, the well-known triad of PBL from those three words, from the first letters, but we would also have to include mechanics. And the main reason to do that is that in most cases, users actually attempt to do what we call gaming the system. So they would, for example, log into an application that awards points just for logging in, just to get those points and not use the application. So they actually learn what they have to do not to use the application well, but to get the points they need to climb up that leaderboard. So one of the main tools that we have to give the sense of evolution actually to our players has to do with what we call in narrative the hero's journey. So it's actually a visualized identification of progression. So what was your performance when you just downloaded and first logged onto the application, what we call the onboarding step, versus your current performance. And when users see that they actually get better when they're using the application, this actually motivates them to come back and use it some more. If they don't see that, then they are more inclined to drop the application and uninstall it or go somewhere else or never use it and so on. Another important tool that we have in the context of gamification, and also Duolingo does this quite well, is identifying the next step. So after you have completed a task, proper gamification scheme should also instruct you on tools and content and quests and where to go next and what tools to try next and so on. So they give you advice, which is actually something that eliminates the process of choice. Users actually do not like to be presented with many choices. They like to be instructed, given, for instance, 3 or 4 different alternatives, and then use their sense of autonomy to choose between all those 3 or 4 choices. But they don't like to be presented with tools that they don't know how to use or maybe are not related to them and so on. And about the notifications that I mentioned earlier, if we don't, as application developers, if we don't pay attention to the content of notification and how often they are presented to users, then they are very likely to drive users away. So if we just send random notifications to our learners that they haven't actually logged on to the application this week or they haven't completed their daily exercises and so on, this, as I said, will most likely drive them away. So again, proper notifications have to do with personalization. For instance, our application can actually identify the time of day that users like to log on to the application and engage in the different exercises. For some users, this may be during school time. For other students, This was actually a time in the afternoon where they had a break between the different tasks they were given or the different after-school exercises and so on. So when we know when it's more likely for a user to log on to the application, this is the time to send them a notification. And also regarding the content of the notification, again, users need instruction. So if we just tell them that, hey, you haven't logged on to the application for a week, as I said earlier, this actually doesn't give them any information on what to do next. But if we tell them that they should log on to the application and complete this, and task, and if they do that, they will be awarded with a new badge, this actually gives them a proper way to go. Okay, it's giving clear and proper instructions to our users. So moving away from the general discussion related to language learning applications, I'm going to start discussing now our work in the area. So this work, as I said earlier, was designed and developed in the context of the IRID project. So IRID was a project funded from the European Union a few years ago, and it had to do with developing personalized content and services for language learning. So we tackled four major languages in Europe. They were English, Greek, German, and Spanish. And it also involved teachers not only um, as part of the user studies, but also as one of the targeted user groups that we wanted to build content and applications for. So we didn't just consult teachers to know how we would design and develop our tools, but we also wanted to empower them during the utilization of the application in school context. So in our application, the content ranges from low-level parts of the language, such as individual words or sentences, to complete passages and books. So a number of the partners of the projects were book publishers, so they were able to give away some of the passages and the books that they had in their catalog. And the advantage for them is that those passages would be included in the school study. So they wouldn't actually miss out on profit from, people not buying their books. Instead, it would actually increase their reader base. The main application was a serious game, which I'm going to discuss in more detail in a few moments. The assorted applications had to do with a reader application, which took advantage of all the language modeling work that was done within the project, and actually was used to from the students to read the passages and the text that were given. A number of custom-made ebooks based on the content that I talked about earlier, and other supporting applications. For instance, we had to build a content classifier to find in proper and fitting books and content for each individual student. In the beginning, all this discussion included teacher and school administrators, because, as I said, involving them would be a major part of actually introducing the IRID applications in schools. We didn't want to make a standalone application such as Duolingo. We wanted to actually assist teachers and school administrators in their everyday work. This is a short video. I'm not going to play all of it, but it would show you some of the mini games that we developed. So in the beginning, let me pause this. In the beginning, students are given the opportunity to personalize their avatar. And this also was found to increase rapport from the part of the user. So they liked the step, and then they would just log into the game to see how they were doing and check on their avatar, so to speak. So they had the opportunity to change their appearance and use additional props such as eye patches or glasses and so on. And then the narrative was presented in a form of a map. The aesthetics and the content of the map usually remind me of an Indiana Jones adventure. So they have to do, as you see here, with jumping over cliffs or solving riddles or chasing different enemies down a river and so on. So, for instance, the mini game on the left over here has to do with splitting words within their different syllables, and more advanced exercises have to do with content related to the syntax. So you can see the URL for the game. It's on Play Store. It's available only for Android, but if you don't have access to an Android tablet, you can install a local installation of Android on your computer or on PCs or Mac, a simulator, and then use the game there. And in the beginning, you will be asked to create a profile, which is the basis, the foundation of the work that I'm going to discuss right now. Okay. So in order to identify the actual mechanics of the different exercises / mini games that you saw in the video, we've had to take into account that learning doesn't happen in just one step. So in the beginning, we wanted to improve the accuracy of the students with respect to each language phenomenon. Accuracy usually has to do with understanding and applying the correct rule when it comes, for instance, to dividing a word to the individual syllables that it consists of. And then the second part has to do with using that information in combination with other rules in a given context. Okay, this usually has to do with the proper spelling of words with respect to specific prefixes and suffixes. And then once they learn how to do that using the different rules that they're presented with, I have to note that all these exercises are in association and they follow the school curriculum. We don't aim to replace what happens in classrooms. Okay, as I said earlier, we want to help the teachers perform their role and make language learning more interesting by giving the students an effective application. So we don't aim to replace what happens at school. We just want to make it more interesting and more effective. So as soon as the conventional part of language teaching completes, then students are advised to use the gamified applications, the mini games. And then by using the rules that they know, they actually find themselves in a spot where they perform the different exercises, they fill in the content almost automatically. And this has to do with both speed and accuracy. And this is the last part of the learning phase, which is automaticity. For instance, when you write the words on or when you drive a car, you don't think about which letters to use or which pedal to press or when to use the different tools in your car or your device that you're using. This has to do with automaticity. Okay, if you complete a task successfully over and over again, then you learn to do that without necessarily putting too much cognitive effort in that. So in the beginning, as I said, students form an initial profile, in our implementation, the initial profiles had to do with the actual level that they were at school. They were 5 years old, 6 years old, and so on. Levels typically have different names in different countries. So, for instance, in Greece, the different levels are labeled numerically, starting from 1. So you start with class 1, class 2, and so on. But in other countries, they are numbered with respect to the age of the students. Now, I know that students are not expected to have the same proficiency of the language when they are at a certain age, but this is actually the profile that they're beginning with. And given their performance and their choices within the different games, the numerical values that the profile consists of are changed. So if they lack the necessary knowledge at a given language feature, then the relevant number will be decreased, and this fact will be reflected for the students and for the teachers to know. So this is just the initialization, so to speak, of their student profile. Now, in terms of the structure that we used a hierarchical structure, sort of a tree-like structure of the user model, of the student model, because we wanted to also integrate some sort of progression. So in the beginning, the starting nodes of the student profile had to do with the first language features that are required for students. Those had to do with specific letters, they had to do with combinations of letters and so on. And as soon as they would master the initial language features, they would unlock the more advanced ones. Okay, so before moving on to more advanced features, we have to present content related to the prerequisites, and students have to display some sort of proficiency on those features. They don't have to be perfect, but they have to be good enough. So in our case, adaptivity has to do with identifying the appropriate content for each given student, and then using their responses to the tasks given to them, to the quests given to them in the context of the mini games, to reevaluate the level of proficiency, the 3 numbers that I talked about earlier here for each language feature. And also this implementation allows teachers to change those values interactively if they want to just proceed to more advanced language features, or they could also prioritize some of the language features. So if one given day they want to teach one specific suffix of a word, they can choose that specific part of the language, that specific language feature to use it for content selection. So this is a graphical representation of what I said earlier. So at the top row of the image, you see the individual starting features, and as soon as each student performs quite well or well enough, as I said earlier, then the feature at the bottom of the graphic is unlocked. It turned to green. So in the beginning, you only have green features at the top, and then given that they're good enough, the bottom one is also unlocked. In the third graphic at the right part of the image, you see that the bottom, actually the middle top feature was turned into yellow. This actually has to do with not only the student not performing well, but it also has to do with revisiting features that students have been examined in the past. So our teachers, during the user studies, they told us that it's important to perform some sort of revision. So when a month goes by since the last visit of a specific feature, the corresponding value of that feature in terms of proficiency is reduced by 1. And when it goes below 7, it's actually reopened to make it available for content selection. So we also give the opportunity to both teachers and students to reevaluate and revisit content that they have used in the past. Regarding the word or sentence of content in the Navigo game, the first part of this selection process has to do with actually identifying the proper feature. As I said, features have to do with specific letters, with combination of letters, with things related to spelling, to using proper prepositions, to prefixes and suffixes, and so on. And of course, each language had a different level of modeling when it comes to those language features. And then we would design games that actually utilize the word and sentence features in the different game mechanics. I discussed earlier a specific game that had to do with syllabification, which is the division of individual words and their syllables. You also saw a game that resembled a riddle mechanism that had to do with putting words in order to form a sentence that utilizes proper syntax. And we also have to take into account that individual mini games would actually also tackle complete groups of features. So, for instance, when it comes to suffixes or prefixes, you want to teach students how to differentiate between the different available options. So you would actually utilize as many as you can and utilize a mechanic that actually asks from the students to choose which is the proper one. So at the end of the day, for a given feature, not all mini games would be available. But as I said, the first part had to do with either the adaptation process or the teachers themselves choosing the next feature to work with. As I said, it was very important to also involve teachers and give them the autonomy to guide the selection process of the content. Now, based on the feature to work with, the language feature and the mini game that was available and relevant to that feature, then the selection process would actually search the dictionaries that we compiled in the context of the IRID project. And this actually was a straightforward step because each of the dictionary entries was tagged with information of the actual features that each word had to do with. So this was actually a part of the additional software and additional tools that we use. So we had to analyze each word in the dictionary with respect to the language features that were utilized. So in the final part of the adaptation process, we had a sort of structure of 3 different items. The first one was the language feature. The second one was the actual mini game to be used, and then the words or phrases or the content to be fed into the mini game. And then the mini game would respond with information about student performance and student timing of the different options and choices. And these were then used to reevaluate the profile in the manner that I talked about earlier. So the idea was that we wanted actually to replicate the process that teachers do when they suggest content and exercises and different tests for their students. So when teachers would generate a multiple choice test, they would think about a sentence, as I said earlier. They would leave out one specific word, and then they would give 4 options. One of them would be correct, and the other would be incorrect. So we wanted to automate this process. First of all, we wanted to help the teachers, as I said earlier, but second of all, we wanted to make the whole process more interesting for the students. Okay, that's one part. The other part had to do with the profiling that teachers actually do. So most of the teachers actually are aware of the competencies of each student, but they cannot be expected to remember when was the last time that they experimented with particular words or sentences. So we wanted to take this burden out of the teachers, so to speak, and give them a tool that can actually automate and speed up this process for them. So this has to do with, as I said, revisiting all the processes that are necessary to teach language. And this doesn't have to do necessarily with a data-first approach, which is the one taken by Duolingo. We wanted to replicate the processes used by the teachers themselves. So after the provision of the triple of feature, mini game, and content to the games, as I said, would return some performance information. Performance had to do with success and failure, and also the time it took for the student to find the answer. So one of the research questions of the project had to do with how often to reevaluate the model of a particular student given their performance in the game. And of course, the impact of this reevaluation. We didn't want to, it's like in neural networks when you have the, you have to decide how to train your, I don't know, your backpropagation network. That's a very old algorithm, but it's the first one that people are taught in electrical engineering. You want to know how which value to choose for the training step. This is actually related to what we wanted to do here. We didn't want to change the student profile that much, but we didn't want to force students to play more games than necessary in order to advance to more advanced language features. So we wanted them to have to play 2 or 3 or 4 games at most in order to advance to subsequent features. Given that in 3 or 4 games, it's more than enough to show mastery. Okay, so we chose one very simple algorithm called the EMA, exponential moving average, to take into account the 3 past attempts of the student within the context of a given feature. So given that the starting value would be 5, then you would have to play 3 perfect games in order to get the maximum and lock that feature and move on to the next one. As I said, as soon as your competence level would go above 7, you would unlock any subsequent feature, but you would still have to perfect that given one and go up to 10. Of course, there was no kind of perfect answer here. This was mostly trial and error and consultation with the teachers with respect to how many games the students should be expected to play before moving on. About the additional content that I talked about earlier, I mentioned some ebooks which were provided by the publishing partners, and they were actually evaluated by teachers. One of the major parts of the initial groundwork that we did within the IRID project had to do with processing for those texts given to us by the publishers and actually evaluating them with respect to each language feature. So in the beginning, that mapping had to do with what is called readability index. Actually, the Flesch-Kincaid algorithm is one of the best known algorithms that had to do with mapping individual passages and text to specific levels corresponding to age. But as I said earlier, this doesn't actually necessarily apply to our problem because students of a given age might display different levels of proficiency with respect to different language features. So we had to actually go through the texts and evaluate them with respect to each language feature in the model that we built. And these were fed to the e-reader application. A very important aspect of that application, a very important mechanism of the application had to do with highlighting specific language features. For instance, at a given day where teachers chose to discuss suffixes, they would easily use the e-reader application to identify those suffixes on the text that students were given to study. And this was also very useful for learners with dyslexia, not only because of the specific language features that were highlighted, but also because we developed a mechanism to progressively highlight the individual syllables that they were expected to read. And as part of the supporting tools that we developed for teachers, we developed a number of profile visualization for each student and for each individual class. And we also developed a number of tools to help administrators sign up and create student profiles in a batch manner, which was very important given that we evaluated the different applications and the games with more than 2,000 students. So at the end of the day, it was not possible to create 2,000 user profiles or student profiles by hand. So what we found out after the evaluation is that it was very important to start with the user studies. And this was actually what we did within the context of the IRID project, but we didn't go in as much depth as we wanted. So sometimes teachers would spell out some requirements. The design and development team would understand something else, and teachers would actually identify this sort of losing in translation only after they saw the tools or the initial drafts of the games and so on. So an important part has to do with finding a common language with your users and try to actually translate that language to requirements that your developers would actually understand. Another important finding had to do with the impact that the design of the language models had on the content choice. So as I said, content choice starts with features, and features are integrated into the language model in a hierarchical fashion. So you have to go through the initial features, the introductory features, in order to unlock the more difficult subsequent ones. So in one particular model, that was the Spanish model, students had to actually unlock a vast number of features. I think it was more than 70 in order to go to the second level. So there was no real progression, and students were stuck in introductory content for eternity. But this, as I said, had to do with the design of the model. It had to do with how language was operationalized in order to be mapped to the actual content. And another important finding, the last one that I'm going to discuss here, had to do with not going to actually solve all problems. Okay, it's not possible. Language learning is a problem with very different facets, very different individual things to tackle and object to tackle and so on. So at the end of the day, we tried to, as I said, operationalize what teachers would actually do within the class and give them tools to do it better, faster, and by using more content. So it's not possible to solve all queries as the one I'm stating in the slide here. For instance, the average of the last attempts for a given student in the context of a particular feature and so on, how well that guy did with suffixes over the past month. So it was not possible to do that given the hierarchical design of our database. If we wanted to facilitate that query, if we knew that we had to answer that query, then we would have gone with a different design. So there's no single architecture, no single design that answers all questions in a proper and fast manner. So regarding the evaluation that I talked about earlier, in the 4 different countries, and also there was another evaluation exercise, a cohort that utilized the applications, the Navigo game and the other applications without the framework of the school. So we found out that all games that we designed were at least as effective as regular class activities. I know that this doesn't sound very promising, but it's actually the first step that we need to take in order to make the school administrators and the teachers believe in that technology. They need to know that it's at least as good as they are in order for them to embrace and adopt this language learning technology. Now, when we compared adaptive games to non-adaptive games, then we found out that in some cases, adaptive games were better, but this was actually not statistically significant. So there were no real cases of automated adaptivity being better than the school mandated curriculum, which doesn't necessarily mean that adaptation is bad. It may actually mean that the experience integrated in the school mandated curricula was actually in the right direction. Okay. Another important finding had to do with low performing children. And so we found out that children with low prior knowledge in the context of specific language features showed larger improvement than children with prior knowledge. So our games helped children which were low performing more than high performance. In terms of non-cognitive aspects related to anxiety, to reading anxiety, we also wanted to tackle the fact that some of the students were actually distanced from the activities taking place in classes. We found out that the games were at least as effective as regular class activities. And this was also the case for adaptive games. They were at least as effective as non-adaptive games. In terms of efficiency, which is what actually parents want to experience, they want to see their children progressing and becoming better at language. So we found out that children need less time to reach the same end result in adaptive content selection mechanism compared to non-adaptive, which means that teachers were using the curriculum mandated content. And the better performing children would spend less time in adaptive content selection than in non-adaptive, which means that faster progression might help them actually progress faster in the game, unlocking the more advanced features and going on to more advanced mechanics of the language. So that was the presentation. I'm very happy to take some questions.
Yeah, thank you so much for the interesting presentation. So there's one question on the chat window in Zoom. The question is, could you describe the kind of loops you encountered in terms of their causes? Were they all caused by the same failure? Why were you unable to eliminate them?
Mm-hmm. So if I understand correctly, the concept of loops, if this has to do with unlocking subsequent features and then failing and going back to the individual ones and so on, this was actually not something that we encountered. So as soon as, okay, thank you, Jim. As soon as students would unlock the more advanced features, then they would proceed as expected. Given that we did utilize some sort of long-term evaluation scheme, so evaluation more than 6 months at schools, the students would be given enough time to forget, so to speak, about the easier parts of the language. But we didn't find that in our data analytics part. So it's, from my point of view, it has to do with language modeling. If language modeling is quite detailed, and thank you, Vishnu, is quite detailed and has to do also with the proper sequencing of selecting features, which was again curriculum mandated in all 4 countries. So sometimes, also being a parent, we don't really trust our teachers, but at the end of the day, the results showed that we should trust them. Then, in most cases, they know what to do. Okay.
Yeah, I think that answers. So thanks a lot, Dr. Kostas. It was really nice having you today. A very insightful presentation, very motivating as well. Really appreciate all your efforts with your project. Just a token of appreciation, I wanted to present this certificate to you. It's displaying on the screen, I believe. If it was
Thank you, Vishnu. Thank you.
Yeah, if it was in person, we could have given you a plaque. We could have celebrated in a more better way. But yeah, in the virtual circumstances, so this is our token of appreciation. And we'll keep in touch and probably call you back later.
Thank you. Good luck with the rest of the event.
Yeah. Thank you. So next we'll have a panel discussion on should artificial intelligence development really take a pause? So the panel will be moderated by Krupa Kotadia. So over to you, Krupa.
Hello, everyone. I'm Krupa Kotadia and a prospective Ph.D. student of Data Science, Analytics, and Engineering at Arizona State University. I'm privileged today to moderate a panel discussion on should AI development really take a pause. Recently, the news media has been filled with reports and debates on the powers and dangers of artificial intelligence. Adding to the confusion, even experts have been differing in their opinions. This panel discussion is intended to help clarify and provide interesting perspectives on the topic. This panel comprises representation of both from academia and industry. Also, I would like to request the audience to please mute yourself, and if you have any questions for our panelists, then you can type it in the chat and we will pick few questions in sequence depending on the time left. Well, let me introduce to our honorable panelists. We have here Dr. Haralambos Patrikakis. He is a professor at the Department of Electrical and Electronics Engineering of University of West Attica. He is founding member of The Engineers, a spin-off company of University of West Attica, specializing in AI and deep learning solutions. He is also the director of the Computer Network and Services Research Laboratory, an MSc program, which focuses on artificial intelligence and deep learning. We have Dr. Vishnu Pendyala. He is a faculty member in Applied Data Science and an academic senator with San Jose State University. He is the current chair of the IEEE Computer Society Santa Clara Valley chapter, and he is an IEEE Computer Society distinguished contributor. His book, Veracity of Big Data, is available at MIT, Stanford, CMU, the US Congress, and internationally. He has received the Ramanujan Memorial Gold Medal and a shield for his college at the State Math Olympiad. We have Manish Mradul. He is currently a director with Palo Alto Networks. He is experienced with managing multiple engineering teams, DevOps teams, and support teams distributed across geographies. Manish worked on multiple releases of enterprise software product and services. And we have Prasanna Vijayanathan. He is a seasoned professional with over a decade of experience in building high-performance applications and frameworks. Currently employed at Netflix, he holds a prominent role as an engineer and lead. His technical expertise and proficiency lie in building high-performance, low-latency applications on web and mobile platforms using data analysis and artificial intelligence. A heartfelt welcome to everyone. And let's start with the very theme of this panel discussion. Are the recent calls for a pause to AI development justified? So from the panelists, who would like to take this question first?
Okay, I can go first.
Sure.
In the interest of time. So This is a very pertinent question, but an interesting one as well. There were chatbots in the use before. There was Siri, Alexa, and DALL-E before. Copilot is nothing new either. And autonomous vehicles and UAVs have been there for a while now. Computers passed the Turing test long back, maybe a decade ago. So what is new is the scale and the unprecedented attention ChatGPT drew, right? So some experts seem to be riding on this wave of unexpected attention, creating news. Research is all about creating anyway. So if at all there is a real concern, we should have worried when the transformer architecture was invented, or for that matter, even when the neural networks were invented. So I do not believe that there is a real need to pause at this time. So I don't think the scare that has that is generated in the recent times is really justified. I don't know what others think.
So Vishnu, I think I agree with you. Like, I believe the transformation has been an ongoing process. We have been seeing this from a couple of decades, and it is a continuous process that has been seen. I think the major thing around this time is around the scale of the work, like the scale at which it is adopted and the speed at which it is adopted. So probably the fears around the economic instability due to the job shifts and probably the loss of privacy is probably some of the major things. I think some of the earlier discussion talked about similar things, but I agree with you. Like, this has been a regular process. We'll see this, and we'll see the counter mechanism coming into the place for the risk associated and the skill level changes. So I think that's the way the industry will go.
I think Prasanna has his hand up.
Yes, I want to plus one both the sides of the conversation, because that's what I've been hearing in other panels as well. I work with other nonprofits that focus on education and improving social capital of students. And one fear that's been underlying all the conversations till now is just is AI going to take our jobs? That's and I feel like AI development and the rollout should be separated out. And I don't see a need to pause AI development or the research to understand and do things better with more focus on the ethical and socioeconomic impact of AI at this scale. However, until we understand the impact of it on the society and how it's going to transform different job roles and scenarios, it would be good to have a slowdown, at least in the rollout, at least not at the scale that we are seeing right now. But I don't know how feasible that would be at a global scale.
Okay, Dr. Patrikakis.
Yes. Well, I think that even the choice of words here should be careful. If we go from the excitement that the large language models have created to fear, then we are skipping all the intermediate stages, which are more important. Concern or worries about the use of this new tool, an unprecedented tool so far, because in the history of humankind, there have been inventions that have drastically changed the way we humans work, collaborate, live. The will, fire, even military inventions, which were not invented for good, such as the atomic bomb. But all these have been tools used by humans, and we always relied on the rationale of humans to make good use of it. Now it's the first time that one of these tools seemed to be able to evolve and think on its own. Well, this is a big discussion what think means. Also, what reproduce itself. might mean, because there are concerns about that. So yes, we should worry about paving a way in that will have this tool be used for the benefit of mankind, and not to repeat mistakes that we've done in the past. A very trivial mistake that we did not see at the time was when internet was created, no one thought about security over internet. And now we are constantly trying to patch up the internet in terms of security. So let us not repeat the mistakes of the past. And definitely there should be no stop here. We should go along with the flow, because if we try to stop it, then I'm sure that people with bad intentions will try to take advantage of it.
So listening to your all concerns, like, is there or isn't there a cause for worry at all?
So I think we need to be prepared and not wait for a catastrophe to happen. Unfortunately, these powerful inventions like quantum computing and artificial intelligence are double-edged swords. And the key to human centricity lies in their usage, like Dr. Patrikakis and others were also mentioning. So at this time, it appears that the technology may not go out of control, but misuse of the technology could. In my opinion, I think there are more pressing needs to worry about in the immediate future, such as the threat to cybersecurity from quantum computing, or sustainable future, the climate change, the weather patterns evolving. So I think those are the more pressing things to worry about than worrying about the transformer architecture. That's my opinion.
Okay.
I would also like to add here that there is indeed a reason to worry, but not about the technology itself, not about this technology. We already have reasons to worry. For example, climate change. This new technology will definitely increase the speed that things are happening. So the worry was there. We are now being presented with the tools to expedite the developments. So if we are to worry about what we humans do and how we do it, we should worry double, or we should think double, because now we have the tools to even expedite our course towards destruction, or reverse the bad things that we have done.
I want to add my thoughts. I feel like there is reasonable concern. So there is, I feel it is okay to be worried to an extent where we can stop and think about where we are headed before we just keep going in the direction things are flowing in, especially because this rollout at this scale has been possible mostly because of so quickly, is because of the organizations that are owning this technology. If you compare it to what happened with the internet back then, most of the technology was driven by academia and universities and government organizations collaborating all over the world. Today it is different in a sense. A lot of it is driven by research and rollout from corporations, which probably have different motivations to roll out than what academia or research might have. So I still feel like there is a concern for the scale at which and the pace at which we are rolling out technologies. But if we are intentional as a global society, if we are intentional about how we want to do it, like for example, there are research that's going on in how to use AI and robotics to build smarter cities, safer cities, sustainability and green tech, even education. Those are all things that can really benefit humankind. And so we need to be intentional about how we are using the technology that we have today. yeah, I think that would be the main concern. Are we intentional about where we are headed and how we are heading there?
Okay.
So just to add to it, essentially, like this is so much groundbreaking for most of the organization that every leader will want to kind of jump into it. Otherwise, it will be fatal for the business. So in my opinion, like the technology is going to advance. What we need probably is a way for or wait for us to fund the academia and the regulations around it, so that can also move at the same speed and kind of counterbalance it. At the end, we need technology. Like we cannot really regulate it through laws only. We need technological advancement. We need the academia to kind of research into it and build the counter technology at the same speed, so that it can be kind of, if not countered, it can be, there can be enough awareness and there can be enough masses to kind of understand the implication of it and build appropriate tooling around it to be able to kind of prevent any misuse.
Right. Thank you all. So as Manish mentioned, like there are many industries that are jumping currently into AI development, and a pause to AI development will affect their businesses. So like even if there is a need to pause the development of AI in future, will the industry heed to the call?
So I'll start. In my opinion, no. So we have experienced this in the recent times as well, right? Elon Musk signed the letter for the pause, but started his own AI venture, right? And Microsoft, we heard that Microsoft laid off the entire team, which was meant to act as a conscience keeper, putting brakes on AI research for ethics concerns. So this is a race, and no one likes to stop in a race, right? So I don't think anyone would heed to the call. That's my opinion.
Okay.
To add to that, the examples Vishnu mentioned are still corporate entities within the same geopolitical boundaries. Think about the whole world and all the other boundaries that people wouldn't respect. So I think even if you're talking about a pause, it's almost impossible to have one, at least with the current state of things. If something like how we handle protecting the ozone layer comes into play, where the world recognizes the risks and comes together, that would be the right direction to go in, but I don't know if that'll ever happen.
Okay, so as per Prasanna, like you are mentioning that it's not possible to pause the AI development, right? So like here comes my next question then. Can AI pose an existential threat in the future?
Okay, go ahead.
Go ahead.
So AI has immense potential, right? Like we all know, artificial neural networks serve as universal function approximators. So there is some basis to fear that AI can go out of control, but I think we are far, far away from there. AI will continue to be in the control of the prompts from the people and the environment. At least with the currently available paradigms, I think that's what it seems like. So even the ChatGPT that is powered by RLHF, reinforcement learning with human feedback, is also with human involvement. The inputs and outputs of the gigantic network are still in our control, however gigantic the network may be, right? Otherwise, autonomous vehicles and drones would have already started killing us, right? It is like this. In this panel, what is the risk that others on the panel or I can go out of control and talk nonsense? probably 0%, right? Because we are still guided by our prompts and the reactions from the audience. Krupa is acting as like our prompt engineer, right? She's prompting us with the questions. So it is very unlikely that we may go out of control. The control of artificial intelligence will continue to be in the prompt engineering space unless a drastically new paradigm is invented, and there's plenty of time for that. I don't think we need to worry about it right now.
I would also like to add here. I fully agree. I fully agree. I don't see any currently any existential threat in the future. However, we do not know how this will evolve. And keeping in mind that if excessive power is given to an automated system that might not be regulated, then we might face such a risk. Then we will simply drive it safely. And whatever the developments will be, we will never have to fear that AI might pose an existential threat.
Okay.
I think it's good to ask a question of what does existential threat mean? If you're thinking of AI taking over humanity and destroying all of us, I agree we are probably very far away and we have a lot more nodes to control before it gets there. But then I feel like we should be wary of more subtle threats to the society and the economy, because economy is what drives our society and maintains sanity. And if those things come under question, and this is why I go back to my point earlier about corporate entities controlling the technology more than academia or government. The reason is the motivations would be different. And then if we are very close to having like good integration of NLP and mechatronics today that can say replace jobs in making a pizza restaurant. Right? That we are very close to that. What happens to the job loss then? And how are we equipped to handle the losses to those individuals and families facing economic crisis? With AI actually replacing their jobs, right? There could be some truth to that fear. And if that escalates without control, then it could lead to at least some level of existential threat, if not completely. So I think there is reason to be wary about it and make sure we at least know what we are getting into. So.
I think one of the concerns which keeps coming is like, can the overall intelligence of the AI can surpass the human intelligence, right? Like that's probably something that I don't know how real it is, but the scale that it is growing, can the collective intelligence bypass, or probably the data point can bypass, and can that happen at some point of which I don't know, but that's probably something to kind of look forward for. If the system is probably designed with good intentions, like probably it is supposed to keep, and it is supposed to keep adversarial out, it is supposed to kind of have the privacy controls in place, but inadvertently, if the system become intelligent, if system has enough data point to be able to do its job at its kind of best, and if that system kind of is able to self-learn so much, then can it kind of sometime overtake inadvertently, not necessarily kind of by design. That's probably the concern, but at this point of time, there is not enough data point to be able to say yes or no. So probably, I think technological innovation will continue, and it has to continue. We just have to kind of look for those signals.
Thank you. So now this question is particularly to Dr. Vishnu, but others can also chime in. So during the recent IEEE conference on AI, Dr. Vishnu mentioned that the biggest concern with AI currently is misinformation at scale. Why is misinformation and fake news difficult to be contained?
Yeah, that's a very pertinent question. So yeah, we had a similar kind of panel discussion in the IEEE conference on AI, which Krupa also attended. So yeah, there was no time to elaborate on that. This is really an important question because hundreds or thousands of papers have claimed great success at detecting misinformation. So then why and how come the fake news is still prevalent today? Some of these research papers have claimed 100% accuracy of their models. In fact, I presented a paper in the same IEEE conference on AI as well, in addition to the panel discussion. And in that project, our experiments show that the current representation learning techniques are not sufficient to separate misinformation from genuine. Misinformation containment has been proven to be NP hard more than a decade ago. So it is, of course, a good candidate for artificial intelligence in that respect. But the fact is that truth is complex. It is temporal, it is subjective, and it is relative, right? There were times when the truth about the earth was that it is flat. It was so blatant. And people who believe that the truth is that God does not exist. There are some people believe God does not exist. And objects that are small are really small only when compared to other relatively large objects. So that's the reason why there is relativity, there is subjectivity, and there is temporalness in truth. Whereas on the other hand, machine learning models used in the current literature are fixed and cannot handle the dynamic variations in subjectivity or relativity. So the other thing is determining truth can require a huge corpus of prior knowledge. See, large language models are therefore a good tool, but unfortunately they compounded the problem. In fact, they are generating more misinformation than truthful information. So that's one of the reasons I still depend on Google search rather than on ChatGPT for most of my information needs. There are several other reasons also. I explained those in my papers, and there's also a video on IEEE.tv explaining more reasons. So I don't know if others have any opinion on that.
I have recently completed a project on fake news over social media, and currently leading my group in another European project again on fake news and misinformation on science. There is apart from the technical part, there's also the human part involved here. The techniques used by people that want to spread misinformation are different than the techniques used by scientists or people that actually deliver information that is valid. So the first ones try to impress you or try to catch you off guard, and while the second are speaking with arguments and the voice of logic. Now, in a time where there is no time to search for information, as you said earlier, where we rely on videos, where we rely on fast food information delivered to us, it's very easy for the people that can pass misinformation to find their ways. And therefore, it's very difficult. And one also important thing is that my truth might not be your truth. My religious, my ethical, my societal beliefs might not be the same as yours. So it's a very difficult thing to say that this is truth and this is fake.
Right.
But to build on this, like somebody's preconceived notion might come in the way of determining the truth, right? Definitely, like that's definitely an area that kind of is a problem, or probably hindering in determining the true fake in the fake versus truth of the media available. But at the same time, probably technology can aid. One of in first presentation in this session was about like how to detect the how to make exams more successful, or probably outside of the bad behaviors. It's probably same techniques can be applied here. There can be technology which can aid into it. Like probably you can have voice anomalies in voice patterns. You can have anomalies in the body posture in this deepfake media that is available, and that can potentially flag some of these. Like what I'm saying is technology can be enabler of identifying these deepfakes, as well as probably the media literacy around like there are deepfakes available. If we can have this awareness in the public so that they can be a better consumer of this information, that can also be probably like something that can help. It will not avoid 100%, but it will probably at least make everybody an educated consumer of this information.
I think this is a very interesting question, because it goes back to us being intentional as a society and where we want to invest with this technology. Do we want to invest in making enabling deepfakes better, or should we invest in explainability of the model so we can, while the video is running, we know whether it's deepfake or not? Right? As an example, so when a user is consuming a video, they would know if it's a deepfake or not, or maybe it's not played at all. Different things that, so it depends on where we want to invest now, and that's where I think we need to again be intentional about where we want to invest.
Okay. Thank you everyone for the insight on this concern. So how do we ensure ethical considerations are adequately addressed in AI development?
So in my opinion, I think AI developers need to have a holistic view of the domain. Often, when a developer is asked to comment on an ethical implication of their software, the typical answer is, "Oh, I'm not a lawyer." This has to change, I think. Just like there is test-driven development, there should also be an ethics-driven development to ensure ethics compliance. For instance, taking an analogy, if a civic construction such as a public building or a flyover causes harm to the public, the construction company is held responsible, right? Similar logic may apply to AI products as well. The companies coming up with all these great tools which can cause harm to the public should be made accountable, at least. But we know how politics and the governments work, so I don't know how much you can trust on that. But yeah, that is my take on it.
Okay.
There's a good.
Here I should add that Europe has already taken a step towards this direction with the AI Act. It's still under development. A milestone was reached mid-June, and hopefully by the end of the year we will have more. And the recent history of GDPR shows that there might be a way to address this issue. On the other hand, the legislation, Japan's legislation on generative AI and the results and how this may be treated legally shows that there is still a long way, and agreements at the international level need to take place here.
Yeah, very similar to that point. I think that's the direction we need to go into. It's first defining what those ethical standards are. That is important. I don't know if AI developers are equipped to do that. It should rather be driven by regulatory authorities, like what EU has done or is doing. I think that is what is needed. Who defines what is ethical in AI? Like, could it be one company versus the other? Probably not, for the same reason why we won't take a pause. But we need the regulatory authorities to step in and define what it means to have ethics in AI and what those ethical standards are. And then transferring that knowledge to developers and asking them to stick to those standards, like what GDPR did. That was a very good example. And I think that would be the direction to go in.
Okay. So, like, we are all aware of the importance of the standards of ethics in AI development. So, are we investing enough in research to develop AI solutions ethically?
Well, I think it is easy to say, but who should invest? Is it the industry who should be investing? It's actually a race, like I mentioned earlier. The race is driven by bottom line, and ethics does not matter so much to the bottom line. In fact, it may even go against at this point. That is, I'll come to some other points quickly, but at this point, it seems like ethics do not matter a whole lot to the bottom line. They do matter, but not a whole lot. So that's the industry perspective. And if you are talking about the federal government, we all quite well know how it works. A few years ago, I read a news item that an assistant professor got the prestigious NSF Career Award for, I think it was for $500,000 or something for a 5-year project. And within a few weeks or months, a company rolled out the same product. I'm not sure what the researcher did with the $500,000 and for 5 years. The Fed recently invested $140 million in the development of 7 new national artificial intelligence research institutes. So these institutes are expected to help the Fed to better understand the risks and also the opportunities of artificial intelligence. But I have my own doubts about it. Only time can tell how much of it really produces the results we need. I mean, I'll probably stop there.
So in a sense, like there is an incentive for people to use this technology for advancement of their product or their whatever they're trying to solve for, irrespective of whether it kind of is completely ethical or not. At the same time, there need to be check. There need to be incentive for them to adopt this ethical behavior. Unless we do that, it's hard for anybody to kind of invest time and money in it. And I believe the best way to do that is either we have technology to assist it or have regulations like compliances. When the payment industry was evolving, there were compliances which came along with it, which essentially ensured that people are storing this information appropriately. Similarly, GDPR came for the similar reason that the privacy is taken care of. The information is well kept and well regulated. So probably something similar need to happen, because otherwise, if there is no incentive, then there is no reason for people to invest money and time on it. There need to be incentive for people to kind of do the right things, and probably that can be a combination of academia plus regulations, in my opinion.
Yeah, thank you all. So how do we balance the need for technological progress with the potential risk and ethical concerns of AI?
It goes back to a lot of things that we've talked about just now. So who defines ethics, who drives it, and who maintains those standards? So I think it goes back to that. We do see the need for regulations and more research on how we're going to use this technology. So that feels like would obviously shift focus and resources from rolling out at scale. So now the question is, will corporates and organizations come together to invest in that? I feel like there is a possibility that corporates will head in that direction, because like recently there was a paper that compared, for example, ChatGPT-4's performance back in March to June, I think, and it saw a big drop in accuracy. So now there are questions about what data are we training on. So there needs to be research on in that sense now. I'm sure those companies are already investing in those directions. But then you do need that investment into research and understanding. And I think we need a similar approach for the ethical standards as well.
I kind of agree with that. Companies should be investing in, like I mentioned, ethics-driven development rather than firing ethics departments completely. And more importantly, I think people should avoid using products that do not comply with the commonly accepted ethical standards. Right, like I mentioned in the IEEE conference on artificial intelligence, responsible AI is everyone's responsibility. For instance, like I mentioned, I still use Google search instead of ChatGPT for most of my information needs. That's because I anyway have to cross-check ChatGPT answers to make sure they are truthful. So that's double the work actually. So in my humble opinion, I think truthfulness is an ethical standard that ChatGPT does not meet. So that's the reason why I think people play a very big role in the whole process of making AI ethical.
Okay.
So I think there's a question on the chat window also. So Jim, I believe, Jim is asking, GPT-4 struggles to reason according to Popper's situational logic, which covers subjectivity and the like. That seems like a necessary objective, but I'm not sure if any is or even, if anyone is or even can work towards it effectively. Like I mentioned, I don't think machine learning is equipped to handle situational logic very well, at least at this time. So I think it is continuing to be a struggle, even for the future generations of GPT. That's my take.
Yes, quantum computing could help to
Yeah,
understand the fuzziness of behaviors.
that has to be seen. Quantum computing provides the power, but I don't know, in terms of logic, it's we are still there's no drastically different paradigm, right, in terms of the logic.
Right. So Dr. Vishnu was very skeptical about the government's regulation of technology in general at the recent IEEE CAI. So what do the others think? Like, what role should governments and regulatory bodies play in overseeing AI development?
The way I see it is there need to be a framework in place. Like there need to be, for example, government doesn't say that this is the technology that we have to use for complying with, let's say, any other regulation that we have. But they said that the end result need to meet these criteria, right? So if there are overview level guidelines and then probably technology can come in play and kind of help adhere to those guidelines. For example, the truthfulness, or probably the previous example that were given is essentially around how do we ensure that the intent is good. If even if people want to, let's say we want to say that people are the driving factor, and people should be able to kind of consume the technologies which are ethical. If government has a framework in place to understand that this is also needed by law, and technology can enable it later point of time to provide tooling in the hand of people to say that, okay, this is really meeting the regulation, or this is people can see it for themselves that how much it is kind of meeting or not meeting. That will help drive the adoption of this ethical framework. Currently, even if people want to do it, they are not aware what is the right thing to do, and second, they don't have right tooling to understand that it works or not. The masses will adopt it if it is beneficial for them. So if there are framework in place and if there are tooling in place, a corporate will be incentivized to build this tooling as well, because they know that if they provide the tooling to help customer themselves evaluate that this is meeting the ethical guidelines, they will also be incentivized to build this tooling. I think the government will play a role of providing the guidelines, and then probably probably incentivize it, and then probably industry and academia will probably follow the lead. That's just my general take.
I would plus one to what Manish mentioned. To add a little bit on Dr. Vishnu's skepticism, I don't know what government is in his mind, but I can relate to some of the skepticism there based on what has happened till now. But I think regulatory agencies can step up their game too. And I think it is needed at this point. So we will have to work together as a society. Regulatory agencies, corporates, people in the society need to work together.
Yes,
the cause for my skepticism was mainly because democracies have evolved to being driven by campaign funds and vote bank politics. So that is, and there's not a whole lot of overlap between the real welfare of people, and I don't know, that's my take, but yeah.
Yeah, thank you so much. So keeping time limit in mind, we have to draw this insightful panel discussion to a close. So today we have engaged in a thought-provoking exchange of ideas, perspectives, and experiences that have truly enriched our understanding of the topic at hand. Our panelists have demonstrated exceptional expertise and passion, and their contributions have been nothing short of inspiring. From the intricacies of technological advancements to the nuances of social and environmental challenges, we have explored the multifaceted dimensions of the issues facing our society today. We have learned that progress is not just about scientific breakthroughs, but also about ethical considerations and sustainable practices. I would like to extend my heartfelt thanks to our panelists for their invaluable contributions, to the organizing team for their unwavering dedication, and to all of you who have joined us today for your active participation. Thank you. Thank you so much.
Thank you, Krupa. I think that was quite an interesting, insightful panel discussion. I just wanted to present all of you with these certificates. Krupa, thank you. Manish, thank you. Rosanna, thank you. And Professor Patrikakis, thanks a lot for participating in this panel. So we'll move on to the next session. The speaker is already has been waiting. So let's quickly move on to the next section, which is on using machine learning tools in the cloud, experience gained from the Ask for Summary research project. So the talk is by Professor Maiga Chang from Canada, Athabasca University. Professor Chang, if you can share your presentation.
Yeah, I cannot share. So can you?
I'll stop my share. So while you share, I'll introduce your talk and yourself to the audience. Ask for Summary is a research project that has a system periodically running backend services to process text-based content. The CORD-19 dataset includes a growing number of academic articles regarding coronaviruses. At present, there are more than 717,000 full-text articles in the CORD-19 dataset. So when Ask for Summary processes this text-based content, it uses natural language processing techniques that include tokenization, n-gram extraction, part-of-speech tagging. It then identifies the keywords from a user's question and uses cosine similarity to summarize the associated content and present to the user. So when the Ask for Summary is fed with course materials like PDFs, Word, and PowerPoint documents, it can provide summaries for students' questions related to the course. Currently, Ask for Summary can serve users via 3 ways. There's web system, there's Moodle plugin, and also there's a chatbot. In this talk, Professor Chang will also share some of their experiences and insights from using Amazon's Comprehend key phrase extraction and syntax analysis APIs in the Ask for Summary research project. Dr. Maiga Chang is a full professor in the School of Computing and Information Systems at Athabasca University, Canada. He is an IEEE senior member. He has been appointed as an IEEE Computer Society Distinguished Visitor and also received the Distinguished Researcher Award from the Asia Pacific Society on Computers in Education in 2022. Dr. Chang is now chair of the IEEE Technical Community on Learning Technology. He is an executive committee member of Asia Pacific Society for Computers in Education and Global Chinese Society for Computing in Education, and the vice president of International Association of Smart Learning Environments. He is also editor-in-chief of Journal of Educational Technology and Society, and has given more than 135 talks and published more than 250 conference papers, journal papers, and book chapters. We are really fortunate to have him with us today. Over to you, Dr. Chang.
Okay, thank you so much. Thank you so much for inviting me to share our experience of using the cloud-based machine learning tools in one of our research Ask for Summary. So my name is Micah Zhang, and thank you so much for the introduction. I think in that case, I don't need to introduce myself further. So, so what is Ask for Summary? So Ask for Summary is one of our research projects we started during COVID. The reason why we want to do this research is during the COVID pandemic, many people, they want to ask some question regarding coronavirus. And there are so many different information on the internet. So people, they don't know what is correct, what is not correct. So, so by that time, actually, several publishers, they decided to open their papers and the publications in terms of coronavirus and put them together into a specific format that in just JSON format, and asking natural language processing researchers in the world trying to create some applications for the users. So that is why we decided to do this research, because we want the computers to read those articles. Those articles are reviewed, are peer reviewed by people. So the knowledge or the content stored in that articles, you can consider they have some kind of accuracy, and you can count on them. And then we found that actually this kind of research is not just about coronavirus. We can actually ask computers to read the course content that you are teaching in the university, or the policy or guidelines in the company. So in that case, your employees, the customers, they can actually ask questions that about the policy or about the guidelines or about the course content, and then get the summary based on those provided content. So that is why we changed the name to Summary Generation for Users Question. So as being said, that summary generation or Ask for Summary, this research actually is trying to read the content provided. And when we provided the content in COVID-19 data set, they are about coronavirus. But if we provide the course content, then the content will be about the subject, the domain area, the knowledge. And then we use natural language processing technique to trying to extract the knowledge, and also use the same technology to find the answer or find the summary, find the related sentence for the users. So that is askable summary. Let's talk about the COVID-19 data set first. That is our very beginning. So the COVID-19 data set is a very huge data set, as you can understand. That is containing about 700,000 articles, full text articles that are related to coronavirus. So including the SARS, MERS, and the COVID. As long as the articles are related to coronavirus, the publishers, they put them together into a JSON format and create this COVID-19 open research data set. So how large this one is, you can consider this data set is about 80 gigabyte pure text data without any image and other things. So there are about 400,000 PDF files and also 300,000 PMC files. You can also tell that the publishers, they're trying to remove any articles they are not passing the review process, or at the end they decided to exclude them from the data set. So from time to time they have more and more articles, and they will also remove some of them. So that is what you can see. And you can also see that during COVID, actually the data set size is increasing. So actually, if we compare the 2 seasons or 2 months data set, you can see that it is about 1,032 articles increasing daily. So every day we will have about 1,000 articles, full text article from 3,000 words to 8,000 or even 12,000 words articles related to coronavirus question. They are included, they are generating. So in that case, that is what we did. We create a so-called askable summary, and the system will read the content. And then if you are a user, you can try to ask your question, and then the system will generate a summary for you. So askable summary allows people to decide how many relevant articles you want the system to look for. And then among those articles, how many sentences you want this system to use for generating the summary for you. So in this demo video, we consider to only use 2 top documents, and for example, 5 sentences to create a summary for your questions. So you can see this is one of the examples. So you can ask, or some users they ask, is COVID-19 deadly? Will it ever be vanish? So when the system read the articles, it decide to generate the summary for you, like this one. And the system also provided the relevance and the satisfaction scoring bar or sliders for users to let us know what they think, so we can even improve our algorithms better. There is no registration needed. So everyone, when they use this system, actually they are using this for anonymous. So you can see in the system, we also provide the dashboard, so people they can see how many content the system is learning when they are answering a question or generating summary for them. So they will be understanding what kind of source included in the summary. So what you have seen actually is 1.0. So when we have the 1.0, we're trying to do some kind of performance assessment. So when we do the performance assessment, actually we are using full processing unit computer. It is a non-cloud computer with only 8 GB memory running the Debian operating system. Just for you to understanding. So basically we are using a very simple computer for the testing purpose. Doesn't like many other researchers they are using very powerful computing powered or very high resourceful computer to do the testing. We are using a very traditional one, very conventional one. Even your laptop has this power. So we are trying to see what will happen when we are using such kind of, you will consider low end or popular computer to do the same thing. Also, just want you to know that, for example, we all know the ChatGPT. So ChatGPT is using GPT-3, and GPT-3 actually required 800 GB memory to load the trained model. So you need to understand that that is a very huge amount of memory that you need to use. So in that case, you can have the whole model loaded on the memory, and then you can provide a service to your users in a very real time and smooth way. So that is what we did. So when we first did this, we found that actually the performance is not really good. Actually, the system required about 56.22 minutes to read an article. That is not really good. But the first thing I would like you to remember is, so this is faster than human being. If I give you an article, like an 8,000 words article, can you read the article, finish the reading within 1 hour? Maybe not. But then I also want to ask you this question. Do you think if we give the same article to 3 people, and one person who read the article very quickly, let's say within 10 minutes, the other one using 1 hour, and the last one spend like 3 hours. So when you see that case, would you say the first one is the best? No, you won't say that, right? Because you know that the reading speed doesn't mean anything. You will say, okay, let's give them an exam. Let's give them a test, asking them 10 questions and see which person has better performance at the end. So you can say, okay, person A reading speed is 10 minutes, and at the end, it's only remember 3 things. On the other hand, maybe the third person, person C, spend 3 hours. However, when we ask 10 questions for him or her, actually, he or she actually got almost 90% correct. So see, reading speed doesn't really mean anything. People, they can read fast, they can read slow. It's an important thing is depending on how much they learn. So, but you can consider that even 56.22 minutes per article, if you consider to give the machine every course content you have for a course in the university, they can still read everything within 1 or 2 days. which means if you open the course and before the semester starts, you give the computer all the course materials in like early 7 days earlier. The computer can read everything, and then when your students they have a question, they can ask the computer, and the computer can provide them the correct summary. So many people you ask me, right now we have a so-called like a ChatGPT. Why do we still need some research like this? We do. Why? Because you know, like a GPT, no matter GPT-3, 3.5, or 4, they are trained by the data set which you don't know. So basically 60% of the data set used for training the GPT actually coming from the internet. And what that means? That means the data, the resource on the internet, actually, they are not always be consistent. They are not always be accurate, and they are not always be related to what you want your people knows. So that is something I hope you can remember. The second thing you want to remember. I will come back to these things later. So in that case, we are saying, how about we use AWS? So because AWS has comprehend, and the comprehend has a different API, including the key phrase extraction and the syntax analysis. So how about we use the AWS virtual machine plus AWS comprehend API and see if this kind of solution can be better. So we try to use a different kind of virtual machine. You can see that some of them, they are memory optimized. Some of them, they are compute optimized. Some of them, they are general purpose virtual machine. You can also see that they have different kind of CPU. So we also try to use the 64 virtual CPU, 12 gigabyte memory, and see what will happen. And the result shows us when you use AWS, it will be 3.2 times faster, but with less n-gram identified. So what is n-gram? In case you don't know, you can consider each of the word, they are n-gram. If n is 1, then for example, comprehend is a unigram or 1 gram. Our key phrase extraction, this is a 2 gram or bigram. And if we say comprehend the key phrase extraction, that is 3 gram. And so on. So you can understand that AWS, if we are consider 4 virtual CPU case, which means just like what we used, in that case, it is about 3.2 times faster. You can also see that if we use 64 virtual CPU machine, actually it can read 1,051 documents daily. So which means higher than the increasing rate. Increasing rate is 1,032 documents daily. Okay. So that is what you need to know. This is the comparison. So I need to bring you back to this point. Less n-grams identified. So you can consider that the AWS actually is the faster reader. But when it read, actually less keywords are identified. So our observations show us that actually ARM CPU thinks faster than Intel-based CPU, thinks faster than AMD CPU. But the memory size influence is not so obviously. So which means you can use a smaller virtual machine to do the same job like what we do, and with smaller memory size. While you can also see that 2 times virtual CPU, 4 times virtual CPU, until the 16 times virtual CPU seems to be faster, but actually it's not really having the linear relationship. So in our case, actually we found that 12 times virtual CPU, 48 virtual CPU will be a better choice than using 64. Now, I mentioned that earlier, so let me use this case as an example. What that means, AWS Comprehend actually retrieve less n-gram. So if your student or any person asks you this question, what should I avoid while writing in English? If you are a person, you hear this question, what keyword you will say, or you will think very important for you to decide how to answer this question for your friend or for your student? What should I avoid while writing in English? For me, I probably will say avoid is very important, right? Because you are not asking me what should I do, but you are asking me what shouldn't I do? I should not do. So avoid is a very important keyword for me to know what I should provide to you. Second, I think writing is also very important because you are not asking me how to learn reading. You are not asking me how to practice or how to train your listening skill. You are asking me specifically writing. And writing in English, they are also very important because you are not asking me how to writing in French, but English. So depending on context, for example, if I am teaching English writing, then I probably will say writing in English is not so important because I know every question will be related to English. So depending on the situation, if you are talking to your friend, then you need to know they are asking you what should be avoided in writing with English. Okay, now you can also take a look at the effectiveness of vaccine. So what will be the keyword you think very important? Of course, effectiveness. You are not asking me weakness. You are asking me about something's effectiveness. And of course, we need to know that you are not asking me the effectiveness of a drug or effectiveness of a car or a gas. You are asking me the effectiveness of a vaccine. So what AWS will provide you? I use this example for you. You can register an account, free registration, and you don't need to pay anything because they provide you free usage. So you can ask a lot of questions as long as you are not passing their word limitation. Then you don't need to pay. So you can try to register an account and go to Amazon Comprehend and try to type by yourself. And you can see the result. So I input, what should I avoid while writing English? And you can click on entity, click on key phrase, click on language. It will tell you what the language this one is. And you can also click on sentiment. It will tell you what the sentiment this input string or text is. And what are the results? taking a look at the result section here. The result is empty. Why? Because AWS Comprehend doesn't think there is any keyword in this sentence. It doesn't really think there is any important things you need to know or it needed to know. So consider that if we use AWS Comprehend for Google search, and I do the Google search for this sentence, what should I avoid while writing in English? If Google search engine use AWS Comprehend, what will happen? It will find any important keywords. So which means Google search engine will not be able to provide you anything because it doesn't find any keywords. This is very important. That is what I said earlier. You have 3 people. The first person who can read the full article, 8,000 words within 10 minutes, but he or she doesn't remember or doesn't identify any important words. In that case, will you say the faster reader is the best? And I also want you to see, if you enter the effectiveness of vaccine, AWS will tell you that the most key phrase is the effectiveness. There is no vaccine because it doesn't think vaccine is important. So once again, consider Google search engine. If you search the effectiveness of vaccine, but Google search engine use AWS Comprehend to identify the keyword, what kind of search result you will get? You will get some articles or some website. Actually, they are talking about the effectiveness of bear spray, or the effectiveness of gasoline, or the effectiveness of a cooler, right? Because vaccine is not important. So this is what we found, and in our version 1.0, we do have some limitation because we only consider the frequent part of speech tag. So what is part of speech tag? Part of speech tag is something like a verb, like a noun, like a adjective, and so on. So we only consider frequent part of speech tag. And that is one of our limitation. And also we have another limitation, that is time span. So our time cost will be related to the size of a material, and also related to how many valid n-grams we can extract it from the content. So for example, if you are using AWS, then the summary can be generated very fast. However, why? Because there is no valid n-gram extracted. On the other hand, if you are using our methodology, because we will generate many valid n-grams, in that case, our searching result will be showing up perhaps, for example, after 2 minutes. So that is not good. So we cannot, right now, we cannot provide it as a real time, like ChatGPT or Google search engine. But consider 2 minutes or 3 minutes or 5 minutes. Do you think it is okay for us to create a bot, like a Facebook bot, or a discussion bot, which when you post the question on the discussion forum, or post your question on the Facebook, and 2 minutes later, we respond to you? Will that be okay? Yes, because when you post something on Facebook, you don't expect to get a real-time feedback from someone managing or running this channel. When you see the feedback after 5 minutes or 10 minutes, you think that is okay, because it's like the chat. You are expecting to have the result very soon. On the other hand, like an email, we can create a bot which receive email and then respond to your email after 2 minutes, after 3 minutes later. So that is what we can do. We also try this, for example, the effectiveness of vaccine, and you can see this is the summary generated. So 92% patients, they were vaccinated with BNT, blah, 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 and so on. So basically, the summary looks good, but it took time. And once again, remember, this demonstration was done with a full virtual CPU machine with only 8 GB memory, and we also record all the time spent, so we can do something for changing. Now, as a researcher, we also not so satisfied with the performance. So we have version 2.0, and when we use version 2.0, we can read an article in average 1.13 minutes. So you can consider earlier we need to use 56.22 minutes. And when we use AWS, we need to use 4.28 minutes. If we use another AWS virtual machine, which is memory optimized one with 64 virtual CPU, it will require 1.37 minutes per article. So you can see that the version 2.0, without using AWS, actually our performance is outperformed than the earlier AWS 64 virtual CPUs version. And we can deal with about 1,278 articles per day with only 4 virtual CPU, which means, of course, we need 1 year and 197 days to catch up all the 700,000 articles. And we need 8 years to catch everything, and including the increasing rate, and then finish all the articles. So that is not good, but consider if you do the parallel computing, for example, even you use 4 virtual CPU machine, if you have 10 4 virtual CPU machine, then the overall the date can be changed to smaller than 1 year. If you have money, you can have 20 more 4 virtual CPU running at the same time. So perhaps you only need to use half a year. If you are richer than that, you can use 40 or even 100 machine running at the same time. In that case, you can get everything very quickly. So with version 2.0, we also try to use AWS Comprehend, and we tested for 6 days. We still use 4 virtual CPU and see how fast it will be. This time, it will be faster, 2 times faster than our methodology, which means every about 30 seconds to 40 seconds, it can finish reading the article. So it's oh, sorry about that. That is 0.56 minutes per article. Okay, so it is faster than us, but not so much. And in that case, if you only use 4 virtual CPU, it will be within 1 year. But once again, I would like to remind you, the problem is AWS will not recognize all the keywords as important ones. This is what I want you to remember. So we do have some performance and trends, and you can actually estimate how much time one methodology can do against others. So I don't spend too much time here, but let me show you the finding. So once again, the observation, we found that actually the computer type of virtual machine in version 2 actually perform better, but not significant different from another machine. And also, once again, you can see that the current methodology still only need 12 times extra large virtual machine, which is 48 virtual CPU. So very similar to the version 1.0's situation. Now, because we have a list, so we are considering how about if we use the course materials in the university or like a policy, taking vacations policy or guidelines, this kind of materials, and then allow our students or customers or employees to use online directly. So that is why we created an English 6420, which is a course content related question answering service that is from a university in Hong Kong. And in that case, you can also see that we only need 2 hours to read all the 45 course related documents. So just want you to know that actually right now, SQL summary can read not just the JSON formatted data like a Code 19 data set has, but also PDF, Word document, PowerPoint slides, web page, and audio recording like MP3 or WAV file. So basically, as a user or a teacher or a company, they can upload almost all the content they have to allow the computer to read. So the computer is not reading content from the internet, but reading and learning everything from what you provide. And in that case, in our version 2, actually, we provide the users to say, okay, do you want to ask question with AWS, or do you want to use which data set or brand? We call brands because the brands is using the Python NLTK methodology, our own proposed methodology, or AWS comprehend methodology to read the content, become a brand. You can consider artificial brand. And so you can decide which brand you want to use. And we also use this way to identify whether or not a reading methodology is better. So in that case, you can see very similar situation when you ask the same question with reading methodology AWS, the result you get is, sorry, we are unable to generate a summary for you at this time. And you can see this result coming out within 0.8 seconds. So that is what I mentioned earlier. Again, just want to remind you, empty result is what you will get. So that is why when you ask the same question with our proposed methodology, it will coming out something, but it will require time. So you can see if you are using NLTK, ask the question, what should I avoid while writing English? You can see it says avoid informal verbs, avoid, avoid, avoid. So all the content actually coming from the course materials. So as a teacher or a company, you will have a confidence that your chatbot or your service will provide the content only provided by you or only offered by you during the training. So here I would like you to remember this. I want to show you this. I will put it on the screen. You should be able to see this. This is what we call Discord bot. And we use SQL summary because we do have SQL summary Python library. So anyone, if you want, actually you can use our SQL summary library, and then you can create your own chatbot with our SQL summaries brand. So you can see that this is a question I ask chatbot, and the chatbot actually is let's say GPT 3. GPT 3.5. So you can see if you ask this question, do you believe in magic? Do you know any spell can be cast for opening a door to ChatGPT or GPT 3.5? This is what you will get. It says, I'm not sure if I believe in magic, but I do know that there are spells can help you to open a door. So, like Open Sesame. And then I ask the GPT 3.5 another follow-up question, which is, when we cast Open Sesame, do we need to use a gesture? And it says, yes, when you casting Open Sesame, you need to use a specific reason and the gesture. So see, this is the problem of ChatGPT or GPT or GPT-3, GPT-4, GPT 3.5, because they are trained with all the data you get from the internet, including sci-fi novels, including those kind of things. They are not related or correct or consistent to what you want your people to know. So this is what you need to remember. And as I said earlier, we do provide the Ask-for summary Python library. So basically, right now you can easily use Ask or Chat to switch to let your Discord bot to use ChatGPT or Ask-for summary. So this is what I want to show you. So this is what you can do the same thing. If you ask ChatGPT, what should I avoid while writing in English? It will also tell you when you write in English, it is important to avoid the informal language, blah, blah, blah. Take a look at something here, and then you can compare against what we provide. Remember, what the Ask-for summary service provided is coming from the course materials teachers want the system to read and learn. So that is what we did. And we try to do the preliminary evaluation and compare against with this two reading methodology. So we have 26 common questions that are provided by teacher. So her students will usually will ask in this academic writing English course. And in that case, when we use this 26 question with two different reading methodology and searching within the three subsets, we will have 156 inquiries. And in that case, we can take a look at this result to see whether or not AWS did a good job. So you can find that actually, if you use our methodology, almost 73% of questions can be answered with a summary generated. But if you are using AWS, actually only 1.28 questions they can be answered with a summary generated. So you can see how different this is. So even a methodology can be quicker, doesn't mean it is better. This is what you need to keep it in your mind. So we also did some other things. So for example, the source created by the two reading methodology, they have a significant difference. That is what you already know. And also, you can also see that if the data set is everything, it will be better, will be performing better. As you can see, 82% versus 76 versus 61. So basically, more data you provide, of course, is better. However, you can also see that there is a significant difference between paper and all data set, 61 and 82. However, there is no significant difference between only documents and everything. So you can see this is only have the difference between the first set and the last set. There is no difference, significant difference between these two sets. And the document set means like the Word document, like the PowerPoint slide teachers provide, and so on. So that is what we did. And we have done this SQL summary for a couple of years, and we are still working on SQL summary research. As I said, right now our focus is trying to make it faster. So we are using something like topic modeling, entity recognition. Of course, we are still using AWS and versus our in-house version of entity recognition and topic modeling. And we will try to see whether or not it will still better than AWS. And we also have another project is trying to use IBM Watson natural language understanding service. So let's see what we will get at the end. And we already have the bot for learning management system in the Moodle. We also have the Guardian, which is living in an educational game. And just like I showed you earlier, we have SQL summary Python library. So basically, you can create your own Discord bot or any bot as long as you use SQL summary Python library. So I think that is concluding my talk. So any question? I can see one question in the chat. How many tokens are optimal for the embedding? So, okay, once again, this is the question which is related to neural natural language processing. We are not using neural natural language processing. We are using natural language processing and statistical natural language processing. We don't use neural networks. So we don't have a so-called embeddings, and we don't care about the tokens because we are not using neural networks. So we don't have an input layer, and we don't have a fixed number of the token things. So when we are trying to do the summary generation, actually we are consider the meanings rather than using neural networks to find just a relationship. So yeah. So that is one of the problem, because when you use neural networks, it will be faster, because once you have the trained model, actually you just have the input as embeddings and the numbers, and then you got the output. So the only problem is when you have like a GPT, you have an 800 gigabyte model, you need to load those 800 gigabyte model into memory, so you can get it calculated everything in real time. So that is a kind of a different approach. But we do have another research is trying to create a large language model for teachers. So as long as they provide their course content, they upload their course content, then we can create a large language models for them, and they can download the large language model, and if they can develop their own applications with the trained model. If they cannot, actually, we do have the chatbot application, which you can load different large language model. So the teacher can ask their students to use the chatbot and supply the model's name, and then the chatbot will use that model to answer students' question. So of course, that methodology can make a chatbot responding everything in real time, but we haven't done any evaluation or test yet. So I hope that I can share that experience in the end of this year or in the beginning of next year. So, and we can see whether or not the SQL summary, the pure natural language processing model with statistical NLP will have praise to compare against with neural natural language processing technique. So let's see.
Yeah, thanks, Dr. Chang. So that is very interesting that you're able to achieve these kind of results even with the traditional information retrieval and natural language processing techniques. So do you plan to use transformer architecture anytime in the future, neural NLP?
Yes. Yeah, that's it. That is what I said. Right now we have another small group of student and research assistant. They are working on the neural natural language processing with transformer, and of course not only transformers, because I was doing neural networks with evolutionary computation. So actually I'm kind of a guy that who is wanting to use everything. So not just the newest one like the transformer, but trying to use those we have learned so long ago, whether or not they can still perform good or better. Because my philosophy is, as long as something can reach your goal, then that is a good method. You don't really need to always consider the latest one or the newest one. You need to always consider not just the one outcome. For example, accuracy, 98% accuracy rate versus 95% accuracy rate. Which methodology you want to use? Most people will consider to use 98.1%, but if we consider other benchmarks, for example, how much time this neural networks need to train, or how much this one can do for improvement training, how reflexibility, and so on. In that case, you may choose maybe 95% accuracy rate model or methodology over than that 98.1%, because this one only required 3 days training, the other one required 1 week training, and this one can be retrained, can be further training, will not overfit, and the other one will. So in my research, I will always consider not just the one numbers, but many different numbers, and then we can decide whether or not we want to have trade-off, and we want to use one over the other.
Just curious, are there any studies that compare the traditional methods with the neural NLP model?
I personally speaking, I don't know. Yeah, that is the problem, because when you use neural natural language processing, you will have some kind of a limitation, and depending on your data set, whether or not you can work on the same application with 2 different models at the same time. I'm not quite sure if we can really do that. But just like that the natural language processing or statistical natural language processing can help you to do a more dedicated things than simply convert everything into numbers and embeddings or metrics and send it to neural networks for the learning. So yeah, but I think that will be very important, and I probably, as I said, once we have our large language model trained, we can actually try to do this comparison with a particular field, that is summary generation, to see which one is better in terms of accuracy, in terms of relativeness, and including the satisfaction. Because we all know that when you ask a question to politicians, sometimes their answer is related, but you are not satisfied. So when we do this comparison, we may consider relativeness, we may need to consider satisfaction, we may also need to consider accuracy and also the training and the reading time, something like that, or generation time. So we may need to compare these 4 or 5 parameters together.
Yeah, thanks. That was really insightful. I just wanted to thank you for this insightful session today, which concludes the ICADS 23, the second annual ICADS 23. So I just wanted to present you this token of appreciation.
Thank you so much.
Yeah. So thank you all for staying with us the 4 hours for the conference. Hopefully you have enjoyed it. And I once again thank all the speakers who participated today, and hopefully we'll be collaborating with you in future as well. Thank you all. Have a great rest of the day.
Thank you.